see here. All this stuff is good. I gotta give it like a minute to propagate and then open the Oh Bother VOD channel. Sorry, I'm a little quiet. Oh Bother VOD. Oh, good, that's already started. We can pop that chat out. We'll mute that. Pop out chat. Yo, that should get all my social stream stuff percolating. We've got events. This is the Cosmo Quest raid from yesterday. It was super awesome. And then Callan27. Did I thank them? That was 3 days ago though. I think I did. I think I remembered too. Hopefully I did. If I don't and you guys are insulted, just tell me. You can just tell me. I'll be sure to thank you. All right, I was watching Flatulent Gonad earlier, and he was doing his usual advice on OBS and stuff like that, talking about how he's blown up OBS a couple times, and I'm like, man, like I need to blow up my OBS. Let's can I clear that one? I think I can refresh it. The what do you call it? My uBlock origin is no longer blocking ads. They'll probably fix it later today, but man, that's annoying. Embarrassment of riches, but not having ads. But it used to be we pay these platforms to not have ads. Now I'm partnered with the platform. I'm making the money, and I still get ads. Is Paint closed on this computer? Yes, it isn't. So I'm going to close Paint over here. We're not doing circuit simulation because it's boring. We'll be actually building stuff. So I'm going to gather a couple bins of parts here, and we should be able to put together some of these circuits that I've been working on. And let's get all our ducks in a row. I got to get my information up too. We don't need this. We don't need this. We don't need this. I will get back to the filter. The filter only needs us to run power and then start testing it, which is it's tough, but I'm going to save this one, and we're going to open a different one. This is another Hajiwo circuit, so there's things that I want to change with it. Things that I want to change. Things that can go slightly different. That'll improve things or just make them more understandable to myself. But before I do that, I need to figure out how these circuits are working, like what they do, what the dog doing, what that dog doing. So we'll put together one of the mutable instruments circuits and see how that goes. Let's see, here's all the switches and stuff. I have more Donkey Kong connectors coming in the mail, like a lot. We'll put this stuff away so I can find things. Need to be able to find stuff. The better I can find things, the quicker these circuits will go together, and the more punchy and interesting the stream will be. Punchy and interesting is something that I struggle with as an engineer. As an entertainer, it should be second nature to me, but as an engineer, you want to get it right. And so there's the ever-present pressure of getting things right and getting things done quickly, and the engineers in the audience have a lot of trouble with that. They don't allow you to do stuff wrong. And so I don't get the punchy stuff where I make a dumb mistake and something explodes. I don't get that because nobody lets me have that. I understand the reasoning behind it, but it's a thing that I got to deal with on the stream. And I like doing things the right way too. I like having an actual cerebral stream where we get smart stuff done. So that one needs a little bit of wiring. This one needs a little bit of coding. The cord VCO is going to need a lot of stuff. But instead of doing any of that, I'm going to go ahead and F off and do my own thing again. I know I shouldn't be, but we'll take a little breather here and do some basic circuit work. I think that'd be beneficial. We can put this Arduino away. I want to use the RP2040. Do I have an RP2040 that has pins on it? I think that's this one. I do indeed. All right, cool. Well, when the time comes, we can use that. Let's see. This one goes away. Not doing anything with Wi-Fi. I don't need much else of that stuff. We got lots and lots of circuit stuff here. Go together. Oh god, I smell like... I gotta put deodorant on. I didn't put deodorant on today. Oh well, you guys can't smell me, and that's the advantage of streaming. Don't know what you are. You're coming with me. All this stuff comes out. What chip we got in here? We're going to try to use through-hole stuff mostly. I'm going to have to jump to surface mount every now and then. Oops. Oh, there we go. Ah, TLO72. Hey, we're in luck. That's what we're going to need today. We try to get an audio signal into this board and then have it get manipulated in the ways that we want it to. And we'll get into that in a little bit. I tried to watch the first episode of Fallout and I fell asleep. So at some point when I'm a little bit more conscious, I have a little bit more of my non-tired self to utilize. I'll try to round out that series. Is the whole thing released? Is that what's going on? There was like one episode yesterday or the day before, and now there's like the whole thing, I guess. But people are mad at it because of a sequence of events that I think they didn't properly understand or know enough about. And I think it's one of those media literacy kind of things with the internet nowadays, is that everybody's looking to pan the show. They want to call it like the worst show ever and how they ruined it like Game of Thrones. And I don't think that's the case yet. I don't really think they have. I saw an artist redo a still image where the main character's butt has been accentuated by shiny pants. And it's like, why did we make the internet? Why do we do this? What are we doing here? What are we doing here on the internet? It's so bad. Everybody just wants to be the next rage bait complainer for something. And yet still, it's the year 2024 of our Lord and Savior, and people still don't understand that a game is a fundamentally different experience from a TV show or movie. There are lots of things. A TV show or movie is a flowing, living product that comes through basically just strife. Everybody is miserable. They get their schedules together. Everybody gets some money in the end, and it's just this living product. It's like, how do you wrangle these people and get them to do things the way that you want them to do in the moment? And actors are providing you with extra information, and you know, the set designers can only do something one way, and so it doesn't quite work the same way. Games, of course, come together in a similar manner, but then there they are. That's the product you have, right? I don't know. Movies and TV show stuff is just so much different of a thing, and I don't think people realize that, especially narratively too. You don't have agency in a TV show, so you gotta tell a story in a particular way. Even people think that like Uncharted is immediately going to translate into a game because it's barely a game, right? there's interactivity and things that you can do and choose to do, but in the end, the plot is sort of somewhat on rails, right? I've never played the games. I don't know Uncharted very well. I know games like that, and it still doesn't translate into a movie. It still doesn't translate into a movie. You want to give your players some choice, right? So I don't know. I think the Fallout series is probably pretty good. I've only watched part of one episode, and I need to see the rest of it when it's available. If it's available. But I'm a big fan of Fallout 2. I played a little bit of Fallout 1, didn't really get into it. I loved Fallout 2. I've clocked more hours in that game than I think any other game that I've ever had. Fallout 3, I had a genuinely good time for it being such a different game. Genuinely good time. Not as many RPG elements as I would like. New Vegas was a masterpiece, and I played so much of that. that I think I've slept in front of it longer than I've actually played it, but I did play quite a bit of it, and I've only done Hoover Dam once. Okay, as a seasoned Fallout 2 player, I just branch out. I just do whatever. Like, I don't care about the main plot. And I did that with Fallout 4. I didn't even get through Fallout 4. I got through a little bit of Fallout 4, and now, all of a sudden, they're making a console update version of the game. I didn't finish the original. There's a lot of mods, though. I might check out some mods and see if I can, like, preemptively fix some things that might be a little bit weird about Fallout 4, and then maybe do a playthrough again. But I've been hankering to play, like, Outer Wilds. I've been trying to like play some actual games, and I just haven't had time yet. The synthesizer stuff and the circuit analysis and then taking care of the dog have all taken quite a bit of time out of my schedule that used to be spent getting fatter in front of a computer. So at some point, maybe I can get back to playing some games and doing some stuff like that. But I have been meaning to play more of Fallout 4. I have not played a lot of it. And especially with mods, maybe there's some like highly rated mods that I can just trust to fix some elements of that game. I was particularly nettled, and I know everybody else was too, by the fact that the dialogue lies. It tells you you're going to say something, and then you say something completely different. It's like, be nice to them, and you're like, you donkey, and you're like, whoa, hold on, wait, I didn't choose that. That completely changes the sort of the personality of what I was going to say. So I was a little incensed by that, and I basically got into the base building mechanic and just stuck there for a while. And I know I'm not the only one. I know a lot of people have had that same exact experience. A while ago, I saw Tomato playing mods for Fallout 4, and it looks like there are some pretty good transformative mods that might be a lot of fun. These are both 10Ks. We'll need these later. I should probably put these into we should make a PCB that's going to bring these out to the perforated prototyping board. I think we need to do that. Let me start on that right now while we're just sitting here. Could I crack open one of my other circuit boards? No, that wouldn't really work. That wouldn't really work. We gotta make an original. We gotta make an OG bother board. Do something like that. This is the My Friend Pedro. Is it My Friend? Yeah, My Friend Pedro soundtrack. I didn't get to play the game. I got to watch a lot of people play the game, and it looked really interesting. Looked like a little bit of fun. Quick little $10 game. I don't know how much Devolver's charging for it. Devolver does a good job. They do a good game. They make good game. Game good. From Devolver. This wouldn't work. Okay. So what we got to do is we just put a pin header on the front of this, and then maybe a couple stand-up pin headers that'll kind of hold it up, so that this can plug into the board and then wire into other stuff. And it'll properly grip down the potentiometer so they don't fall out. And I get a nice clean breadboard out of it. I don't have any like breakouts for this particular kind of potentiometer. So one of the steps is going to be drilling out the holes so that I can put the stands through and actually have them grip stuff. So let's get this out. Let's get a sizable drill bit. Actually, it doesn't need to be a big one. I think we can use... Well, this one doesn't go through circuit boards. This one does. So this is the one. I think that's been modified for plastics. And we'll get this thing. I'm having trouble finding game soundtracks that are, like, not actual real music. They need to be, like, specifically made for game soundtracks. And then they... I should talk to that buddy of mine that came here through Facebook, because he does game soundtracks. I wonder what games he's done soundtracks for. I think he said during that stream, I think I uploaded that stream to the VOD channel. I should check that out sometime. But, yeah, I'm struggling to find game soundtracks that'll work for stream. It's got to be original music, but then it has to be, you know, free and open. It's like the FTL soundtrack. That was a really good soundtrack. I could do like Deltarune, but I think that's played out. Two categories in your mind? What you thinking? Time scroll. Huh. Ones that are like movie soundtracks and ones that are like Valve soundtracks. That's interesting because my friend Pedro, which we're listening to right now, was a little bit more valvey. But the problem is getting into a soundtrack like this and what was the other one? The one cyber game where it's like you're killing your boss. Oh, whatever that one was called. It's one of my favorites, but I want to build the helmet from that game. Anyway, the soundtrack for that game is actually an original producer, but their music is like serious music, so it's not just game music, and so they're copyrighted. I'd be reluctant to play that music on stream. Because, like, there are, you know, like, oh, let me play the SSX Tricky soundtrack, right? All kinds of good music in there. Well, no, their agreement has lapsed, and so it's still copyrighted music, right? The gameplay videos can just be cursed from that era of games. Yeah, and movie soundtracks, of course, are going to come up as movie soundtracks. All right, so those two are ready to solder. I got to do holes in the board, and I got to make the board the size of two of these next to each other. I'm only going to do two knobs, so I'm going to move that over by 2 pins. So we'll go from the beginning here all the way to... Oh, this has to go like way up. Okay, so like that, and then this one will be right next to it in the interest of saving space, and then I'll cut... Actually, I could put the anchor pins right behind them. Yeah, maybe I'll cut it directly. So hold on, let me... First off, I don't want to break those flush cutters. AI musician. No, I don't want to do that. I mean, the closest that I get to AI musician is the modular synthesizer. And the modular synthesizer could potentially sequence and create near musical things that I could put as background. All right, so first of all, we're doing one from the top. This thing's a little awkward, but it works as sort of a near field drill. As in something I can get to. Wait, will these fit in these holes already? Oh, they'll actually fit in the holes. Never mind. I don't need to do that at all. Yeah, just a little bit of pressing. There we go. Okay. Oh, that'll work out much better. I don't have to drill anything. This is My Friend Pedro, the soundtrack to that game. That silly game. Man, Devolver makes some bangers, don't they? They make some good games. It's those Scandinavians. I think my favorite shitpost on the internet was the Scandinavian developer. Like, people wonder why we make such great games, and he's like, look outside. And it was like horrible snow everywhere. Like, it was a total blizzard. And he's like, it's like this most of the year. They're all stuck indoors, so they gotta make their fun. You know, you can't always take album cover shots of your heavy metal band in the forest. Sometimes you have to develop games. Why isn't this working out? These are like bent to hell. They're all over the place. I gotta clean them up a little bit. Gotta clean up the pins a little bit in order to get this thing to go in. Yeah, AI is going to be a real son of a bitch in a couple of years, isn't it? It's going to be real difficult for us to function with it around. We'll be like, oh, I love that song. Wait a sec, nobody made that song. Some kid with a prompt typed in all of the keywords that are most popular with the music that I like. And it created this original song. Oh, I hate it. Oh, I hate it. Okay, that just stuck itself together. I'm going to have to get the big tip on this. I'm doing this at arm's length, and so I can't really see what I'm doing. Gotta pick a new genre every morning. I'm gonna do dubstep today. Some company with an AI that's got a whole paddock full of lawyers. It's me, Executive Man, here to ruin society. Look at how efficiently I do it. Why is the solder not coming off of this thing? I feel like there's more solder now. Yeah, that whole thing's going to be piping hot. Nope, not piping hot. Maybe that's the reason why it didn't solder right. Okay, let's see if I can get this one in here. These are all the support components that I'm putting together. Things that we're going to need in order to test out these circuits that befuddle me. Should be going in that one, and then how many between? That one, then 3, and then the other one. Yeah, so this should be right. Just got to get it to go in there. I think some of these need to be flattened a little bit so that they actually go through. I almost got it, except for this one pin that's fighting me. Nope, it's still fighting me. There are people here collecting the carpets to clean, so there's going to be some overhead noise. I don't know if you guys will be able to hear it. Every now and then you hear. Art is an overused term. It's mostly links back to science. No way, man. Come on. I stuff like that. Like, do you know art? Have you seen art? Have you done an art before? I've done an art. Art and engineering are very closely linked. That's not to sell art short, though. All right, now I can cut this one and know that it's right here. There we go. Almost there. I mean, music has a science to it. I certainly am exploiting that. All right, cool. Now all these pins will solder, and I can have 2 little test 10K ohm pots for my breadboarding. I don't know why I haven't done this before. The song's a little drony. I don't know what's going on with it. Just an interstitial song. Connective tissue for the game. I'm gonna have to desolder a lot once I'm done. Hold on. We'll get there. We'll get there. We'll get there. Yeah, one thing AI can't do is get that trance that you get into when you're playing music or singing or doing whatever. Maybe it's always in a trance. I don't think I have a spare display. I might have one, but I don't think I have one. So there's a limited amount of traction that we can make in this. Maybe she's a solder sucker on this. Just trying to get my ducks in a row before I start here. Good VSTs. I only have a couple. I only have the free ones that I use on my microphone. Ow! Damn it. I keep doing that. I keep hitting my thumb on the hard edge of the plunger. Oh, come on. I'm not using the microscope right now, so I feel like I'm miles away from this. I keep feeling like, oh, because I'm hitting that right there. Okay, so we go higher angle. There we go. We're trying out some op-amp circuits today so I can figure out what's going on with them mathematically. I understand some of the circuits that I'm using here, but there needs to be a gain circuit in there, and I could just do it with another op-amp, but I've discovered other circuits that I would like to know what they're doing, like a timbre circuit that I think is utilizing feedback in a particular way, and it confuses me, and I don't know any of the principles or math behind it, so the best thing to do is then to jump over to perforated prototyping board and actually build the circuit, which is easy enough to do. It's just an op-amp circuit. It's not that scary. Not that scary. I probably should have done the other side of the board first. I don't think I should have soldered these yet, because now I got to put pins on the other side to support everything. Let's get 2 3-pin headers over here. Man, that really hurt. I'm going to draw blood one time on my thumb when it catches this hard edge right here that this thing catches on. I guess it's kind of hard for me to communicate how uninterested I am in solving my problems with AI. Because I'm very uninterested in doing that. There's no growth if you use something to just give you answers. It can help as like a study buddy sometimes, but its propensity to lie to you in order to satisfy the language the language model is disturbing to me academically. Makes it hard to trust when it's been shown in lies constantly. It is helping a friend of mine study nursing. He can generate practice questions ad infinitum and then have the AI go over the material for him and help him out. Apparently that's pretty useful, but... And that, of course, is playing into the fact that it is a language model. So it is trying to perform communication. Although, at the same time, it's not necessarily an information gathering model. So I don't know how it's gathering information. Well, through very complicated plagiarism. At least he doesn't call himself a prompt engineer. Yeah, I'm a prompt engineer. Wait, why are you hanging up on me? Yeah, I live in the valley. One there, one here. Actually, this would be better if I just did it on the prototyping board. I can figure out where everything goes. Now, I'm not going to hook up the support ones because I don't know where they're going. You know, it depends on the design of the potentiometer. It depends on what you want the potentiometer to do. It depends on what you want the potentiometer to do. There, geez, enunciate, bother. What's your problem? Start slurring all my words together like I've been drinking. Oh, God, of course it's an uneven number. I thought I left 2 in the middle, but I guess they just... Sometimes they don't line up. And you're like, is it my fault? Is it something I did? Yeah, it's your fault. It's something you did. You did this. What? Is that still not? Okay, up 1. Well, there's plenty of room for circuit stuff to go on. All right, now that lines everybody up, and it also pulls the heat away from the headers so that I can solder this now with impunity. And now that'll plug into the side of the board and give me a nice little solder thing. I'm just gonna start stream. Get the music. Get the face cam. Get over to the face cam. Where's OBS? Where did it go? Hi. Welcome to Friday. I didn't stream on Thursday because I had to help people carry things up and downstairs. Now there's the carpet people are apparently coming out to pick up a bunch of carpets from directly overhead, the room that's literally over my head right now. So there's going to be some bonking noise and stuff like that during the stream. I hope you can tolerate it. I have not been very responsible. I've been keeping up with uploads, but instead of working on the stuff that I should be working on, coding an LED engine for the VCO, the voltage controlled oscillator, getting this project done, I have jumped the shark. I've jumped over to another project, and that opened up the opportunity to do some stuff that I really want to do with, what do you call it? I've opened this up to making a display module, and this is another Hajiwo project, so it's like a cheap display module, but it does show the waveforms cleanly, and it's a lot of fun to have on the modular synthesizer. So I want to build one. I want to build three. I want to build one for Julian and one for Dave so that we can get them in here and have them play around with their synthesizers, and maybe, just maybe, this will inspire them to teach a little bit. I'm girlfriend, so the only bread I can have is breadboard. Is there a language barrier in this joke? I'm not sure. DST needs a couple things, needs a little tuning to get done. The diode ladder filter, I need to continue to hook up. I need to just hook up a couple more things, and then maybe it'll work. Maybe it'll work directly off the bat. That's unlikely, but maybe it will. I don't know. Who knows? Oh, girlfriend free. Wouldn't that be GFF? I guess people do girlfriend as one room, one word. All right. Anyway, yeah, it's Friday. I didn't sleep much, but we're gonna get into building stuff with the breadboard, the electronics breadboard. The cool thing about breadboard is this is a way, and it's called a solderless breadboard. This is a way to build circuits without using solder. And so the first thing I'm gonna do is start soldering. I need to make something to hold potentiometers that don't necessarily fit in the perforated, in the breadboard. I need to use perforated prototyping board to build a little tiny adapter for my potentiometers. And then we have everything we need to play with operational amplifier circuits. I've got a frequency generator that I can use in order to create input waves, or we could plug in some of this stuff, but I'm probably gonna need the plus minus 12 volt power supply for this instead of for something that'll make waves. But then we can see the effect of the waves as they go through the device and the designs, and then we can see what the parts of the designs do. So we're going to be doing a little bit of math today, or maybe I'll just be introducing you guys to some of the math that I've been working on in the background, and we can then put together a circuit and test it and see how it does. But first, I need these potentiometers. So I'm going to finish this up, soldering together a little adapter board for the pots, and then we can get to looking at the schematics for the circuit and what the circuit does or does not, and then take a look at what it does and does not in the physical world instead of just in math. Because there's a certain point in which I start staring at equations and everything just becomes white noise, and I have to stop, and it's much better to work with actual circuits. So maybe stuff will blow up today, who knows? Anyway, let's get back to work here, because yeah, I got to deal with all the weirdness that chat brings into my stream. Be like, this is off-brand, ban. All right, so let's get this slightly smaller soldering iron so I'm not soldering all the pins together. And what I'm doing is basically just adapting these. Oh, who makes these? They're not alphas, but they're an alpha design where their patent has like lapsed or something like that. And so this other company has been able to make them. Alps, maybe? Who makes these? These are... Oh, I don't know. Hold on, I've got a bunch of them from DigiKey over here. These are the ones that we can get from DigiKey. That's why I ordered them. But these are... Who the hell? I know it's not Ecosonic. Assembled in China. I don't know. PO915N. EC15BR 10K, pot 10K ohm, 120, plastic linear. They don't put the manufacturer on this, do they? Oh, TT Electronics, there it is. So it's from TT Electronics. They make an alpha-like potentiometer, this one here, and I like these. These are what I'm using on most of the synthesizer. So let's just get some of these things soldered and connected. Now, I'm not connecting the ones in back. That could be convenient for hooking this up to power and ground, but I need these to be able to be fully configurable. I need to be able to hook up whatever I want to it. Yeah, let's do this. There's a big muscular arm. So I'm putting this in the solderless breadboard in order to dissipate heat and to keep these pins aligned while I apply heat to them. The pin headers are not strong. They're actually quite bad at handling heat because they use cheap plastic, because pin headers are cheap, right? They extrude a rod and cut it in little pieces and then mold it into plastic. It's a very industrial process, and it is supposed to keep the price of these things as minimal as possible. I bet the margins on these things are super low. You order them by the bushel, and you go, wow, those are really expensive. Why were they so expensive this time? And then you forget that you paid that much money for them, and then they become completely disposable in your setup. Because of their cheapness, you have to make sure to baby them. And to baby them, I plug them into this thing. This thing is a series of little metal clips, and those metal clips will soak up all that excess heat and keep it from melting your pin header. If you're really into pin headers, you'll watch all 14 Hellraiser movies in a row, and then you'll lose your mind, which is what I did. First 3 were fantastic. Well, okay, I wouldn't say fantastic. The first one was fantastic. The other 2 were good. And then every one from then on was a downward step in a spiral leading to the very gates of hell in terms of quality. Yeah, made by the finest ABS, made by the lowest temperature plastic we could find. Okay, look at that. That's a very smart little setup. Oh, we're not done yet. Actually, I gotta hook up the potentiometer pieces, the actual, things. This can only plug in certain areas, huh? Otherwise, it doesn't quite line up. Wait, is one of these crooked? Yeah, they're all a little bit crooked. But if I go here and here, and then these go there, that should all, what the? No, it's just a lot of things have to align for that to go in. I guess they were all a little bit crooked. I probably should have wiggled it a little bit first. Okay, so next step is getting a piece of bare wire and just connecting 1, 2, 3, 1, 2, 3. 1, 2, 3, 1, 2, 3, 1, 2, 3. These are both 10Ks, so these will match up to this design. Doing this without a microscope. If we do any additional soldering, we will be using the microscope, and I think I need to make the negative 10 volt supply. I think that's the next piece of soldering that we need to do. And then we'll hook this up to the Agilent power supply so that I have plus and minus 12 volts available, as well as this as an additional voltage in case I need something that's not a wave, and I can use the whatever it is, the frequency generator that I have in order to create the frequencies. We never fixed that nice professional frequency generator that somebody sent in. That thing is pretty cool. I think I need the microscope to do this. I think I can't see what I'm doing. I think it's all just a blur even through my glasses. Yeah, all right, so I need the microscope. This is for me, not for you, chat. My thumbnail is just going to be this picture of my hand. There we go. I can kind of see what I'm doing, albeit through a shadow. But at least I'll sort of know where the wire is. So the makers of Kingdom Come Deliverance are doing an announcement soon on their latest project. I don't know what it is. I don't know if it's a fully fledged game or if they're just updating on stuff. I remember Rob Oz loving Kingdom Come Deliverance. I never played it. My knife. Oh, my knife's on the other table because I was doing RC car stuff. Check this out. I don't exactly get why this is, but apparently narrower wheels means better steering. I didn't do narrow wheels. I've got these big, thick, super soft. These are 5 degrees bricks, so these are practically chewing gum. These will stick to each other and weld themselves together if you let them touch each other. But I did all this work to make a spoiler for the back, and then Short Lurker convinced me to use that same spoiler in the front as sort of a time attack car. I don't think the aerodynamics are quite there, because this one is straight flat, and then this one goes like that. But I don't know, maybe it'll help stick it to the road a little bit. Push comes to shove, I can always redesign this and make it twist upwards. But I thought that was pretty funny. And then, of course, I got these new wheels, and I was able to put the super soft tires on it. And these are so soft and rubbery, they actually stick to this floor really well. They also pick up everything on this floor, so I probably need to get a piece of tape and run it along this in order to clean it off. But when I get this outside, I'm gonna have to see how this does on pavement. I'm mostly interested in top speed right now with this thing and retaining my grip on top speed. So I'll see how these tires last. They're probably better for like carpet than for like pavement. I don't know what the ideal tire for pavement would look like on an RC car this small. Probably metal wheels to get a little bit of weight down on it. Well, metal wheels to survive the inevitable 75-mile-an-hour crash. But I tried looking up stuff about like why would you choose thick wheels or thin wheels in front and thick wheels in back. I mean, I understand you want the thickest possible in the rear so that you can get grip on acceleration. But the frame is all-wheel drive, and more rubber equals more better, right? I thought you would only do thin wheels in front just for efficiency. And if you've got a touring car, why would you not want to square off all the corners? Because you've got power in front and you've got power in back. So it doesn't make much sense to me. All right, we got to get this one soldered. This thing should still be primed at this distance. Steering feel, but you're going through a servo though. You're not, it's technically not, I guess it would be response is maybe the better way to phrase it for me to understand. That's what it is. It's for me to understand. It's not necessarily the way somebody would. Whoa, that was a big click. Uh-oh, hopefully we don't lose power. If we do lose power, I dump the stream and we reconvene another day. I have a generator, but that doesn't mean that any of the network equipment is going to survive. My see with the generator, there's a brief downtime between when the power kicks out and when the generator kicks in. And so all of the computer equipment in this house, including the networking equipment over in the other part of the basement, are on backup power supplies, right? But uninterruptible power supplies. But I'm hearing clicking from this thing, and we just had a big rainstorm come through. So Pico's doing something. Oh, there's another click. Pico's doing something, switching the networks around, and sometimes that means that we go down. So yeah, you're translating it to real cars. Yeah, there's so much. It's kind of interesting, and I could probably write a freaking PhD about this, even though it would be a PhD in being a 10-year-old. The physics between an RC car and a real car are similar, but due to the difference in size, there are some things that are just fundamentally different. Like, for instance, having a spring steel plate on the bottom of the RC moves your weight more downwards. Apparently, the king of having a really good responsive RC car is having that weight as down low as possible. You can also get a motor that completely outpaces your ability to grip and turn. It's too easy to do. You get $20 and you got a motor that can blow your car up, which is what I did. So it's interesting. Like, and then again, like what I'm talking, like, look at that toe in. Look at the toe in on the rears. Like, that is just bothering me. But apparently this is really important in order to keep your stability. Hey, Caravos, how you doing? But like steering responsiveness, I would think that a larger contact patch would affect change over your direction better than having a thin wheel. Having a thin wheel would probably mean you have less rolling resistance on it. So if you have a pan car that only has rear-wheel drive, I would understand why you would want thinner wheels up front. It's a strange balance. And then I guess in order to fit them to bodies, you would have different offsets on the wheels. I haven't even gotten into the bodies yet because all the bodies for these RC cars, they're all cool cars. I don't want this to be a cool car. I want this to be the dumbest car I could possibly find. I want to put a Satsuma body on it and make it look like the My Summer Car. Ended up getting the board programmed. I remember you had issues with it. Which board are we talking about? So the one that needs to be programmed is the VCO, the voltage controlled oscillator, and this works. We got all the different functions for it working. It needs to be tuned. I need to make sure that 1 volt per octave is properly maintained, as well as I need to build in the LED engine to tell you what mode you're in. It needs to blink the number of times for the mode, and that means setting up a matrix of timing values that gets iterated while flashing the light on and off. And that's just something I have to code up, and it's super boring, and so I've kind of sidelined it for just a little bit while we work on the diode ladder filter. That's not the diode ladder filter. The diode ladder filter, which is another Hajiwo design that I think I've slightly modified with an op amp, but we've got a diode ladder. No, this is an unmodified Hajiwo design. Diode ladder filter with a bunch of caps, and we're mostly done this. I just need to hook this thing up to power and ground, make sure the powers and grounds get everywhere they need to be. I did a little bit of work with that, but this one is also sidelined because I want to build a display, and in doing so, I got into a lot of circuit design stuff that we're going to what the hell happened here? Why is that enormous? What happened there? What the fuck? Hold on a minute. Hold on a minute. Why did that get enormous? I didn't touch anything. Properties. Refresh. I must have hit a control button or something. That'll probably fix it. Well, let's just see. Yeah, it's a digital napkin sketch. Yeah, that's what I do with paint. Actually, more comfortable doing that. Okay, there we go. Jeez, that was weird. All right. Close that. Put that chat up there. There we go. I can see everything. All right, let's move this over. Oh, I have to go into edit mode in order to move it around. Darn it. All right, whatever. I'll just stay there. So yeah, we'll go over a little bit of what's going on here in terms of the math. Op amps are not that hard. There's a couple specific equations, you know, that you got to look up and know. But other than that, it's crunching a bunch of numbers. Let me finish this up though. I gotta finish this up. Getting distracted by all the stuff. Like for instance, the kit, the Atom SZ2, sells much harder springs. They sell multiple different levels of springs, and they go to much harder levels than they go to softer levels. And I would assume you would want softer springs on the thing, because having it super hard sprung would mean that if it hits just like an atom, like a difficult atom, it'll fly off of the track because of all the spring force on that. But I'm not an RC car specialist. I'm just an amateur. Maybe people who actually race these things know. I keep looking stuff up and finding weird information that I don't quite trust. I used to get RC car magazines and read them. I used to know some stuff, but it defies knowledge. Institutional RC car stuff. And I've had a lot of fun with the 1/24th scale just because it's like, you can put it in your pocket. You can put it in a little box and run around with it. I can jump outside for just a little bit and be a complete, I don't know, kid. Oh yeah, I've seen those before. The Japanese mouse mazes. Those guys do what I wanted to do with one of my microcontroller courses at Drexel. One of my microcontroller courses at Drexel, we worked in this lab, and the lab had one of those configurable mazes in it. It was a much more rudimentary one than the ones they do for the Japanese competitions. And so we had to program these microcontrollers to try to run the maze, figure out what stuff it bumped into, and avoid it. And I actually built in a, what is it, a quadratic equation? No, it was a much more rudimentary than that. What the hell was it? It was just like a triangle. It was a Pythagorean theorem. There we go. I used the Pythagorean theorem in order to make it go diagonally across some of the obstacles, and then I ran into some troubles with it, so I hard coded it to do that, so there wasn't actually any learning going on, and then I ran the maze. And the TA was completely fascinated with what I did. And I was like, yeah, you know, this is what I tried to do. And then when I did the write-up, I said, this is what I tried to do. And this is what I did. And what I did was I put in just some hard-coded timings in order to get it to run the maze, to look like it was running the maze intelligently. And I got a really good grade. I got a really good grade. And I probably shouldn't have gotten a really good grade. But I was honest. I shouldn't have done that. You know, is it cheating if you just blatantly admit what you did? I guess it's programming if you admit that you stole it. But I didn't steal anything. I just hard coded it to do what I wanted it to do. Because at that point in the actual like whatever it was, the lab that we were doing, I was verifying that my code would come up with the right numbers. And so I needed something as an example of the right numbers. And then I ran out of time. So as per usual, I bit off more than I could chew. It didn't really, look, the purpose of the lab was to have the mouse run the maze, learn the area, the times that it should turn, and then turn at those times, right? So you had to have it run the maze, then you had to press the button, and it would commit everything to memory, and then it would do it again. It would run the maze again. So a little, excuse me, a little bit of tuning of my timings might have actually gotten me there, but I didn't have time for that. So technically, I did not finish the lab, so I should not have gotten such a good grade. Maybe everybody else did so badly they just decided to have mercy on me. I think moreover what it was is the TA was grading a lot of stuff very quickly and was probably had a hangover or something, and so they just gave me the grade. You know, in a perfect world, they saw how smart my idea was and said, this is the future, and they gave me a good grade. But I doubt that. Okay, so now that's all wired up. So now we have two 10K potentiometers that we can take advantage of. We got to look at the circuit and we got to figure out what the hell I'm doing. Now that I have these test elements that I can call upon. What is that? There's a little piece of solder on the end there. So yeah, these are the two pots that we're going to use. One of them is for timbre, T-I-M-B-R-E. It's a musical term that I don't really know exactly what that is. And then the other one is for modulation. Modulation and timbre. This is a circuit that I came up upon while looking through Mutable's instrument circuits and looking at how their designs are done, because Emily Gillette of Mutable Instruments, let me clean up some of the desk here so I can properly explain, does stuff with 3-volt microcontrollers, and she does stuff by actually creating PWM values that'll become audio signals, and she takes outside inputs and scales and tunes them in order to work within a 3-volt microcontroller. So that's pretty much the name of the game for this display module. Instead of using an Arduino Pro Mini, I'm going to use this Pico Pi, which is a lot faster, but it's only 3 volts. And so we need to cater all the circuitry in this stuff to 3 volts. And this is essentially going to be an oscilloscope that you have on your modular rack. Now, the way Hajuo has designed it, he's using his typical diode clamp, which means you have 2 Schottky diodes. So you have fairly low voltage Schottky diodes here sitting on both of your clamp points. So you have one on the positive clamp and you have one on the negative clamp. And if the signal coming in through all this stuff, even the voltage divider, gets too big, then, or too big or too small, it's going to activate one of these diodes. So if it's like 0.7 or 0.3 off of the voltage. Jojo de Yolo. Jojo, thank you for the sub. That will be 10 months of Jojo. Hey, thank you so much for subbing. I really appreciate that. Wish I understood the electronic encode better. I'd love to make one of the mice RC. Oh, those, yeah. It's not that bad. Those are not too complicated. And I'm sure there are tons of tutorials on that sort of thing these days. I mean, back in my day, the line following robot was the big cheese, I should say. The line following mouse was the big cheese. But one of the things about the line following robot, I remember a friend of mine who got into electronics a little bit before I did. I don't know, he's like a doctor now, and I'm just this dumpy guy in a basement. One of the things he was ranting and raving to me about was how like you have to get all these parts in exactly the right places or it doesn't work. I'm like, well, yeah, that's electronics. Like at the time I was like, wow, that's insane. You can't make any mistakes. Yeah, anyway, we were like 10 years old. Nintendo was very big back then. So, okay, we're looking at a Hajiwo circuit, and this Hajiwo circuit is displaying all kinds of cool oscilloscope stuff based on the input from your modular rack. If we look it up, I can show you guys what it looks like in the end. So we just do like Hajiwo YouTube. I still don't think he knows. Oops. I still don't think he knows. I shouldn't have put a .com on there. I still don't think he knows that I'm doing all of this content of his by rebuilding a lot of this content. I'll have to put up a GitHub page at some point and maybe link him to it at some point. Display. So I looked up display on his list of stuff. DIY modular synth oscilloscope and spectrum analyzer. Now $7. I don't think this is $7, but this has a Fourier transform mode. It has an oscilloscope mode, and it can be shifted by 2.5 volts, as well as the gain can be tuned. So you can end up with good looking waves like this coming through and being able to see what's going on your modular synthesizer. And since the modular synthesizer is modular, there's much less complexity to this than there would be with a traditional oscilloscope. You have 3 modes, right? So we've got a gain knob that amplifies the external input, and then we have you can select whether or not you want a voltage offset on there. And that pretty much gives you access to all the stuff you would need to you would want to see out of an O-scope. Now I'm going to build 3 of these. One's for me, one's for Julian, one's for Dave. I want these guys to have some kind of a cool little module that gives them an idea of what's going on. $7 only taking consideration of the module and the bill of materials and the board numbers. Yeah, I think Hajiwo doesn't cover stuff like the front panel and the knobs. I think it's like fundamentally it's $7. I think there's probably a breakdown somewhere in this information, but $7 and I don't know, pre-pandemic priced. Like I don't know what he wants for the perf board. There's a lot of stuff that I feel like is swept under the carpet for the cost of this thing, but I think it's relatively accurate. I think we're like below $20 for the whole thing, especially if you have a 3D printer and you can just 3D print the front panel, which I do have a front panel that utilizes these screens, so that'll be a nice, easy thing to do. I mean, it's a little bit of work, but it's the right amount of work for this stream. There were some comments below about some of the things that he could do a little bit differently on this one. I have the whole schematic up in MS Paint. So the schematic is here. And so what he's doing is he's using an SPI OLED. I accidentally ordered some I2C ones, but I got SPI. I have a question if you can help with 3D printers. We have a whole section for 3D printers on the Discord. If you want to ask, if it's a short answer, I can answer here, but I am trying to actually get something done right now. So we have a push switch that's an internal pull-up, and then we have a rotary encoder that, again, I guess he's putting 0.1 UFs on it. I don't know whether that's necessary or not, but I've got rotary encoders in my cabinets, so I've got a couple of those. These are on the way, so we're not going to be able to do anything with the screen today. But then Hajiwo does some weird stuff with the circuit, and I have spent a little bit of time yesterday and the day before getting to know how the input of this circuit works, and I've got a moderate amount of grasp of it, and I've shown my work. So if we come all the way over here, we have my analysis of this circuit. So here's the analysis section. We get over here and we look at our input voltage as reconfigured by Obother. So I have reconfigured this voltage section, and I'm ignoring the switch right now. What the switch is doing is it's defeating the DC element. So if you have an offset DC, it will turn that into an AC around 0. That's what happens when you switch in this 4.7. Oh wait, it's DC defeat, right? Yeah, DC doesn't go through. AC's all wiggly, so it gets through. So yeah, this would be if you want to put in an audio signal, I guess this puts it down onto the right level. So since modular synthesizers are all juiced up on voltage because they're sort of, they don't want loss, so everything is like 5 volts and stuff. So you're all juiced up on voltage. The first thing you go through is this voltage divider. So we have a 10K and a 4.7K. So the ratio is essentially 10 to 4.7. If you put in 10 volts, you get 3.15 volts on the outset. So what that's doing is that's limiting our voltage down to a usable range of a 5-volt device, I suppose. And I don't know, I put this into a voltage divider calculator and it gave me weird results. But it's, if you put 10 and 10 in there, it's half. So 10 to 4.7, it's got a slightly different ratio. 10 volts becomes 3.15. So the next thing that it does, and this is actually wrong, this is not what's happening here. The next thing that it does, or actually, yeah, maybe this is what's happening. It actually limits our voltage between 5 volts and ground. What happens with these Schottky diodes is you lose a little bit of voltage through here. Here, Discord. Okay, where did that, huh? I had to print something for a friend, usually go 0.28 and solid looks fine, but I tried 0.15 and did some odd layer things that look hairy. Huh, I don't know, that might be an extrusion rate thing. So if we're doing plus minus 5 volts into here, right? What this clamp is gonna do is if we go over or below 0 volts, because Hajiwo has ground going in here according to his schematic. So according to his schematic, we are going between, actually, is that, yeah, 5 volts would be the maximum for the microcontroller. So yeah, here we got 5 volts, and here we have ground. So if something goes horribly wrong with your voltage divider, I guess the voltage divider can be offset by 2.5 volts. This is the part that I don't quite get, is how we're going to replicate this. But if this is at 0 volts, this is also at 0 volts. We don't go below 0 volts, which could damage the microcontroller. And what happens when we go below 0 volts is there's suddenly a potential from ground down here to our negative signal over here. So if this goes below ground, then we have volts that are present here, and this ground can then go through the diode and cancel it out. Same thing with the 5 volts. If we go above 5 volts, then there is potential for 5 volts here to flow to our regular 5-volt supply, because it's electronics is all potentials and differences, right? So when we go above, these just simply clamp it and keep it from damaging our microcontroller. But my problem is, like, if we go below, if we have a plus minus 5-volt signal, right? We have a signal coming in and it's both positive and negative, and then we're clamping it to the negative, to ground here, then it can't go into the negative. So I don't like this design. I don't know what's going on with this design. And perhaps that's maybe what the 2.5 volt offset is helping us with. Maybe the 2.5 volt offset puts that up into the range where we can actually utilize it. Look into extrusion. Yeah, there's some good guides for 3D printing, and I don't remember what the one is. Fatanon linked it to me a while back. Okay, so that's what's going on here. That's what the voltage divider is doing. That's what the diodes are doing. We're taking our voltage down to a particular level, possibly offsetting it 2.5 volts from ground, and then we are punching it through a protection circuit that should almost never get used. It should pretty much never get used unless you've got some big transient to filter out. This is just my logic on that one. And then once we do all that, we have another circuit in here that uses a 10 kilo ohm resistor as well as a 10 kilo ohm potentiometer. So what that does is that biases us from either having, well, the equation for a non-inverting, that's what this is, non-inverting op-amp circuit is Vn times 1 plus our this resistor over this resistor. And so what we end up getting is from this coefficient right here goes from 0 to 1, and this one's already fixed at 1, so we have 1 to 2 gain. So we're either 1 for 1 or 1 for 2. This only amplifies. And so this only amplifies it. It puts it into a 5 volt compatible A to D. So I guess we could probably get up to 6 volts if this thing is a little bit too aggressive. But over here we've got, 10 volts turns into 3 volts. So if we have a full-blown 10 volt signal, which we should probably not get on a modular synthesizer, if we have a full 10 volts coming in, we could potentially hit the Arduino with something like 6 volts. So it'd be 3.15, which wouldn't trigger the Schottky diode barriers, and would come into the amplifier, which I don't know what voltage access this thing has. This thing probably only goes up to 5. That would be the protection that I would do. This op-amp only gets access to a 5 volt rail, 5 volt and ground, then this would just saturate at 5 volts because we would be doubling it. Of course, then after that, we go through a 9 kilohertz low-pass filter. And I tried to run the equations on that really good low-pass filter site. I still don't really know what's going on. Supposedly, this is filtering out anything above 9 kilohertz because the microcontroller can't really handle it. And I wonder what the RP2040 can do because it's a lot more powerful. But the weird thing about this circuit is what Hajiwo decided to do was put those grounds to a microcontroller pin so that when you want to, you can activate and deactivate this low pass filter instead of like a bypass, which would be, I guess that would be a more interesting way to do it. Would you take this and go to a different analog? You'd go to like A1, because then you just have different taps and the A1's voltage is not affected by 2 1 kilo ohm resistors that are in the path. I don't know what I'd want to do. Maybe I'd want to do that since the RP2040, the whatever this board is. What's this one called again? Raspberry Pi Pico. So the Raspberry Pi Pico has multiple analog inputs, so maybe I just utilize two of them and bypass. That might be a good idea. They're all high Z inputs, so it shouldn't really affect it. It's just those two 1Ks I feel like would do something to my, I guess they would be current limiting, which isn't necessary. It wouldn't do anything in this one. So bypass to another. Analog input. So I'm putting this over to the Pico Pi. So I need this circuit to function in the way it does, but for 3 volts. And so, the way to do it traditionally would you'd put a 3 volt op amp over here. You would clamp it to 3 volts. This would then be, I don't know if those would be the same values. And then our 2.5 volt offset would probably need to be, well, maybe still 2.5, but 2.5 and 2.5 is 5. So maybe you'd want half of 3. So that you're biasing to your DC level. I don't know. I don't know exactly what I do there. I started to piece that apart and figure that out after I was done, and relate it to mutable instrument circuits. So in the mutable instrument circuits, what we have is we have a negative 10 volt reference value. We have our plus minus 5 volt that's going into a 12 volt op amp reference to ground, but it's biased at 2 to 1. So you have a 200 kilo ohm and a 100 kilo ohm. Now that doesn't directly translate. What that does is that comes out into the equations as 33 over 200 plus a negative 10, or no, multiplied by a negative 10, sorry. 33 over 200 multiplied by a negative 10 plus, and again, these are equations you could look up for op amps. So plus negative 10, it's basically the feedback resistor over the input resistor times the voltage input. So 33 over 200 minus 10, that's fixed, plus 33 over 100 plus or minus 5 volts. And so that's 0.165 times negative 10 and 0.33 times plus or minus 5 volts. So it's 1.65 plus or minus 1.65. So that would be 0 to 1.65 times 2, which is 3.3 volts. And then you take the negative of that, since this coefficient is negative, we invert it again. That's where the negative 10 volt supply comes in. So the negative 10 volt supply is shifting everything, given its bias, it's shifting everything to be an appropriate center point so that you have your center point that's above, well, in this case below, it gets inverted. So your center point is positive 1.65 volts, and then you go plus and minus from there within your 3 volt range. Where basically, this is the Arduino map function that we've created a physical circuit for. And because the MPC 6000 and whatever, it's not a 12 volt, hold on. 3v3 max. This cannot hurt the rest of our circuit because it can only go between 0 and 3v3. So that's mutable instruments designed to get a control voltage into the rest of the circuit. And this can also be applied to audio circuits. So I did a little bit of searching around, and I went to look for circuits that might be doing something similar to what the Hajiwo circuit does. Basically, we are taking our power in and scaling it. So we scale it, limit it, and then we amplify it up to double. We need to scale, limit, double. Can we do that all in one op amp? That's my question. I don't know. And I guess I can do that just by authoring the op amp on my own and figuring out what all the stuff is going to do. We have a 200 to 133K. So if I put another 33K on that, then that could potentially, would that double the gain or would that halve the gain? Or should it be a 3, should I have a 3K and then a 30K? Ugh, okay, well, 3K, no, that doesn't work. It doesn't work. Hold on, okay, I gotta think. So the question is, like, what do I do in order to get back there? And the second question that I had is, does Mutable Instruments do this anywhere else? And so that brought me to this circuit here. This circuit here is from Braids or something like that. I forget the name of what this is from, but this is doing something funky with the 10 kilo ohm resistor right here and some kind of an additional feedback that I don't know about. I ran the equation for it. You can basically see it as a summer. So here's the negative 10 sum. Here is this weird feedback sum. And then we have the original sum here. So it's 100K, whatever's left of the 10K, 49.9K, or 1K, 10K, 24.9 fed into 24.9, 49.9. So what you end up getting is this really confusing function, and I don't think this takes feedback into account. So I don't know if that's, because I think maybe our timbre is created with that feedback, and I'm not factoring it into the rest of the design. But you have 49.9 over 24.9 times 24.9 over 100 or 100 plus 10, 100 to 110 or 100, yeah, it's 100 to 110. 100 to 110, okay, times the voltage input. And then whatever's left of that 100 to 110, okay. So that would be whatever's left of the 10K on either side. It's like, I could do an equation for that. I'm not going to do that. But whatever's left on the other side ends up in the 49.9 over 100 to minus, or 100 to 110K, times V in plus 49.9 over 200 times negative 10. How does that come out in the equations? I don't know. But I kind of wanted to find out a little bit more about this and what it was doing and what timbre looks like. So that's where we are. And I decided, this was like an hour ago that I was looking at this. No, we're an hour and 50. Okay, so it was like 2.5 hours ago that I was looking at this. I want to see what this does. I want to see what this does to a waveform. And the best way to find out what this thing does to a waveform is to hook it up. So I've got all these parts. Some of these parts may not be through hole, but I definitely have all of these parts somewhere in this shop. Let's put this circuit together. That's kind of what I want to do. I want to have a little bit more of a hands-on day. Whoa, I just clicked on something. What happened? Hold on, get that back. What is that? Wait, this is what the? Oh, that's a snipping tool, never mind. Sorry, I'm getting confused. I got a lot of windows open right now. Okay, there's the circuit. I got that up on the other machine. We've got a TL072 right here. I can probably use something that will help me plug in. Let's make like a single entry plug-in for the modular stuff. That'll be nice and quick. This will only take a second. Because I'm basically just going to take a Thonky Kong and put it on one of these things, and then do some header pins below it. That'll get us all the stuff we need for any future breadboarding, but we haven't done any breadboarding in a little while, so I think it's time. Maybe I should do 2, just in case I have an input and an output on the same thing. We'll do 2. I have a bunch more Thonky Kongs coming in the mail. I don't know when they'll get here. Let's see. So that's the one that encounters the tip. Well, these go to ground. But I probably should have all 3 splayed out individually for this thing. So if I do these sideways, maybe I can do like anchor, and then have 2 sideways connectors. And then I'll break out all 3 of the pins, just in case, you know, something funky is supposed to be going on. We do 3. Just in case. It seems like these things have a minimum of 3 inputs. We'll, of course, only be using 1 today. I can't fit 3. That just won't happen. Unless I twist them, and I don't really want to do that, because then it's harder to wire them. So we'll just do 2, and they'll be really close to each other. And I'll give 1 row of extras on the end, so then that means cutting it right here. That'll do. So these both have 3 pins, so I need 2 more 3 pins and probably 2 more 2-pin connectors, and we'll just put that together and get that running. Get that running. I need pin headers. It's over here. Should have plenty of 3 pins. So then once we have these 2 elements, I can start putting together the actual circuit with resistors and stuff. Now, I do a very neat and organized breadboard. I don't let things get chaotic. So as usual, this may take a little bit more time than we anticipated. It may take a little bit more time than anticipated, but the answers will be forthcoming, and solderless breadboarding is at least a little bit faster than me soldering an entire circuit together. And with these 2 test boards, the little the potentiometer board as well as the input board, we can really kind of hit the ground running for any future stuff that I want to vet out, because this is a step that I've kind of skipped in our other designs. Yeah, there's all kinds of commotion going on above me right now, because they are grabbing our carpets to be cleaned. We haven't cleaned any of the carpets since we moved in, and I guess that's something that needs to happen. Who knows? Maybe I won't cough as much once it's done. It's been bad here. It's been raining for like a whole month. We haven't had a break from rain in a while. I wanted to take that RC car outside yesterday, and because it was gorgeous. And then it started fucking pouring. Okay, so 3 and 3, just like this. Leave 2 on the end? Yeah, maybe 2 on the end. I move this so I can do this one. And then I'm not really going to be able to fit 2 on the other side of this, am I? Like, I guess it'll go in. It might be making contact, though. That would be bad. Maybe I could just solder one of them, and hopefully the other one doesn't make any contact. So this needs to be like this, and then that'll be my two little connectors. Dang it. Just doing one at a time. One at a time should get us there. How much in the way is my hand? Pretty much in the way. There and there. So we saw the Conan O'Brien Hot Ones. one of the greatest Hot Ones ever. Because Conan does not back down from crazy comedy stuff. Actually, this one should be up 1 from the other one. Because they're a little bit, they're sort of both kind of uneven. That one goes there. And then that one, the other one will go. So pin 1 matches up with the signal pin. Oh, that's the wrong way around. One up from there. Okay, so that'll be my Funky Kong adapter for any future endeavor. And then I guess what I'm going to do is I'm going to run the wire underneath and then pop it up from where it was. I can't just ground the pins because I don't know necessarily what the configuration is going to be in the future. For some reason during this rainstorm, my insulin pump has been running like triple duty on me, and I don't know why. It's required a lot of insulin to like pull my levels down from where they were. I don't really know why. It's nothing that's been particularly fatty. I think my body just decided to kind of fight insulin for a little bit, which I guess happens every now and then. How's everybody else doing? Everyone completely underwater this week? That's what Philly's like. We're under the water. Let's see, before I do that one, I should probably solder this one. And before I fully solder this one, I should do its pins here. I don't know if this one's going to work. I think I'm just going to leave that one unsoldered and just have it as an anchor. So then I can put this in here. Actually, if I move it down 1, that's not going to get too far on the way. Yeah, that'll be good. I'll move them down 1. There'll be a blank row up above these, but that way, these are completely uninvolved with the other pins. Wait. Oh, yeah, okay, that's right. Strange. So this one here, like that, and then this one right up next to it, and this one all the way out here. There we go. See, and now that's outside of the housing. And I've got one little row of holes here for the wire to poke up from. This one I can solder from this side, so I'll do this one first. Then I can lay the wire down, because this one's going to get real close. So that's that. Wire. What happened to my wire? Where did it go? What have you done with it? There it is. I'm just using scraps that I found on the bench. Go this one in. Make sure the solder gets on both sides of the wire, otherwise it's gonna cold weld, which cold welds are very, very annoying. Go. I'll anchor down the rest of this. These are simple adapter boards, so it doesn't require a lot. I don't have to be careful about like shorting stuff out or just simple stuff. One, two, and you got to kind of bend it into place. These are specifically ordered from a Chinese company by Thonk, who sells them, obviously, and they're hard to find otherwise. You can probably order like 10,000 from the manufacturer and get a very similar connector, but these ones are like the good Thonky Kong ones. You got to be careful because there's two versions. One of them has a circular style top, and it doesn't have that metal lip. That square metal lip is super important when you're putting stuff together in a synthesizer, because if you over tighten the nut on the one without that square lip, it will extrude the threaded metal part through the housing and break it. It is a terrible design. It's the worst. But avoiding the terrible design is done simply by purchasing the correct connector from Thonk in the UK, which I hate to do. There are more local places that do have them, but Thonk has a very good price on them. They're not trying to rob you. They just have their special connector that everybody loves using. And it is a nice connector. I mean, it fits directly onto this thing very easily. Cold weld made me think of the cold hot soldering irons from 2006. Oh, those were just, yeah, those were a specific kind of graphite that just completed a circuit and heated up. I used to have one of those. The problem is that the tip of it is incredibly fragile, so it made for a very, very bad soldering iron. Just because you couldn't maneuver it into stuff, it would just explode. All right, so there's that. Now I got to do the other side, and then I got to run 4 more wires. Let's see, this one would go to, yeah, the next, oh, that just goes straight over, okay. Yeah, those are such a rip-off, those things. You use them in electronics class? They were not that good. It's just like, toughen up. I need a special soldering iron that doesn't burn me. Oh, I used a long header and a short header. Uh-oh. I hope that doesn't affect the end result here. Burns are like bullets. You can build up an immunity to them if you keep exposing yourself. It's a little bright, isn't it? Oh, it's so bright. Huh. I got weird lighting these days. I don't know what's going on with my lighting. Actually, it does look particularly dark over here. Hold on a second. I think I need to calibrate this camera. Set up arm procedure. Wow. Yeah, I don't know. It still looks pretty washed out. It's strange. It's a weird lighting setup today because the sun's down, I guess. I don't have that little bit of extra sunlight in the background, in the far background. Get a lighting expert in here. Right. There's like all manner of anti-production stuff going on today. There's construction out there in the neighborhood, and it's like just up the hill from where we are, so you can really hear it. I can hear them using like angle grinders and stuff. Then we got carpets that are getting like lifted out of the room from directly above me. It is a mess today. Oh my god, then there's motion at the front door. I used to go to Motion nightclub. All right, open that up. This header I'm a little worried about. Go over here and solder this one. At least this way, visually, you can kind of tell what's connected to what. But you don't know what is what. You just strut. Make sure those aren't connected to one another. Oh, that was the wrong one. Those aren't connected. All right. All right, now the question is, do I want to go down and over, or do I want to just go straight to it? I think I want to go over, because that way it'll seem more like it's, it'll communicate that it's connected to that pin a little bit better. So what I'm going to do is go up this pin. Just hold on to that, clamp this. Tweezers in. I need solder there. I need solder. So once I've done this, the circuit should hopefully go together pretty quickly. Assuming that I've got all the parts that I need in through-hole versions. If not, I'm going to have to make some through-hole adapters, which are not hard to do. It's kind of fun to do, but that just means putting a female header down on the board and then running a resistor across the two pins. Oh, that works out pretty good. Like this, and then the pin tool. Where is my pin? Oh, there it is. I remember that was like the heyday of infomercials, wasn't it? Infomercials were huge back then. I guess they still kind of are. But, you know, you had the pre-allegation slap chop guy. Still alive, Steve Irwin. No, wait, he didn't do infomercials. Who's that guy? What's his face? The shouty guy. The other shouty guy. Billy Mays. There we go. I had to think of like the full shouting voice. And then you get the people who can't function in daily life. I can't carry all these car washing things at once. I can't make breakfast. Like, are you having trouble making breakfast? Apparently all of those the dip-a-tap board adapter for all. This isn't that universal. Apparently a lot of those products, a lot of those infomercial products, helped people with disabilities. And like nobody ever talked about that. It's like, I didn't know. But apparently like people with mobility issues and stuff really benefit from products like that. So that's cool. I didn't know about that. It was just funny to watch all the people in the commercials fail at everything. How do I open door? I don't mean disabled people. I mean they were perfectly functional people being buffoons for the sake of highlighting how functional a equally buffoonery style product was. Oh my god, my life is saved thanks to this egg chopper. Yeah, I can't wipe my floor. but look, this thing will help you air fry stuff. And the one recently where I've actually had to make that argument with my folks is that the one where you scan the QR code and it automatically does the toaster oven baking of the stuff in the tray. And my folks are like, who would need that? Like, why would you be so inept that you're unable to set a toaster? And it's like, well, there's disabled people who don't have that kind of mobility, and it might free them up a little bit so they can live their lives. So that's one of the things that, like, I didn't know that I had to consider back then. But it's interesting to know now. What are the two that I need to attach next? That one's already attached. This one's already attached. So it's the same deal. It's this one and then the one next to it. So that one right there, middle pin, goes directly over. My little method of producing circuit boards. I don't want to clamp the wire in. Hold on. Pull that up a little bit. These will be useful in the future. I'm building for the future here. Here, if you guys were here, maybe my hands would block it a little less. You guys could actually see what I'm doing. Unlike myself, who cannot see what I'm doing. I like building test setups. It's a chance to be really, really organized. Kind of put something together that functions nicely. I had to do that to help one of my teammates on senior design project, and I ended up building a completely professional D to A and A to D converter with wire wrapping in record time, because I had done the lab already and he needed to finish like proofreading, doing the final proofread of our senior design project essay. I was like, look, I can help you. I have a certain set of skills that I've developed over a long career in school while slacking off. I have a certain set of skills that I've developed not working on schoolwork that can benefit us today. Yeah, I need these things in order to test circuits that I don't understand. And I want to find, there has to be a mutable instrument circuit that does what I'm hoping to do, or I will just simply put another op amp in the path of this Hajiwo circuit, and then I'll have the ability to boost the amplification of the signal by a factor of 2. Okay, second one. And now, number 1, the larch. So this one goes from right here. And that one goes straight over here with as much of this left over as I can get. And let me put some solder on the pin to start off. And then tin the end of the wire. Where's the end of the wire? It's right there. I have a bunch of caffeinated soda for the first time in a while, which makes it a very bad time to quit drinking. But my ability to go to sleep has almost been deleted. But I'm hoping to not OD on fucking caffeine today and get shaky hands as a result. Hands are actually very, very steady today, in spite of the caffeine. Usually caffeine doesn't affect me all that much. So a little bit of ADHD, a little bit of already high blood pressure. Oh, did I not solder this end? Whoopsie daisy. We'll fix that in a minute. Fix that in a minute. What happens when you go a mile a minute on the stream? Oh wait, no, that's the one that I'm currently soldering. Welcome to my goldfish situational awareness. Goldfishian. Yeah, that's one of those sketches that lives in my brain permanently. Along with Gamble, Devon, Philipputty, and Thrasher, the Bingle Bangle Bongle Bongle. I used to have that memorized. Of All right, and then final connection. You guys can kind of see, it's hard for me to maneuver the camera on this. I'm trying to work faster. Never bothered remembering that one. The reason that I memorized it was because it was impossible to memorize. So you can quote Monty Python to me all day of the week and I'll know what you're saying, but I'm hardcore enough to know Devon, Gamble, Putty, Thrasher, or Bingle Bangle Bongle Bongle. Weissenmeister, Neschel Switch. There's a whole part of it that I took a long time to memorize, and I'm sort of remembering it right now. There's some cobwebs on that. Got a Dinsdale Piranha. We have, well, Flatulent Gonad just does my hovercraft is full of eels. Mine dicky old chum. All right, let's get this. Are we on? Is this thing? Yeah, it is. Okay. You have to tap this thing like you're like Rodney Dangerfield going, is this thing on? Because it'll turn itself off in order to save you from a house fire. Kind of like vapes should. I wonder why vapes don't have a, I guess probably the better ones do have a temperature lockout, but it just hammers away at that lithium-ion battery, and then the battery shorts itself. Johann Gamble Putty Devon Ostfern Schlemperden Schlitter Karkisch Karkrenbon Fried Diggerdangle Dongle Dungle Burstin von Nackerthrasher Apperbanger Hauerwitz no, I don't remember it well enough. Horowitz Tikolenzik Gander Naughty Spangle Tickle Grandelich. I had it phonetically memorized, and so seeing it in like actual text doesn't help me, unfortunately. Listening to the sketch would. That's like the best way that I can do stuff, is to phonetically memorize it. You don't need to know the words, you just need to know how they sound. Bitte in Nürnberger, Bratswussel, Gespritzen, Miswemash, Luber, Hansfoot, Gumbobader, Schorendanker, Kabelswitch, Mittelanger von Hackelfloft of Urn. Yeah, so I know it phonetically, not by the actual words. That's what I did with the Leak Spin song, which is a Finnish, I guess, folklore song or whatever, where a lot of it is just gibberish. But I wrote it down phonetically and then memorized it that way. And I got most of it memorized before I let the cat out of the bag. I couldn't wait long enough to not use it on stream. And this was back when I had a bunch of viewers. And one of the Finnish viewers was like, I'm so glad you spent the time to learn our language. And I'm like, your language is gibberish. I memorized it phonetically for the memes. I still feel kind of bad for saying that, but it was funny at the time. All right, so now Finnish is fine. Flatulent Gonad is learning Finnish just so he knows my summer car better, and I guess to be a better world citizen or whatever. But I'm American. I speak the language of the world, American. Learn burger speak. It don't even come by. I don't want to hear that British English either. That shit is fucked up. Bring beer. Okay, so we have, for all intents and purposes, most of the stuff that we're going to need in order to build this circuit. At least like hard-mounted stuff that we're going to need. Our output is going to go directly to the oscilloscope, but for now, we need to figure out how to build this thing. And what I'm trying to do is I'm trying to figure out how in the hell this... I'm gonna burp. Oh, I burped. I'm trying to figure out how in the heck this op-amp circuit works. So let's try to build it without the microcontroller present. Even though it's meant to go into a 3-volt microcontroller, I'm just gonna get big and wide, or than I already am, and build this circuit on the breadboard with the 2 op-amps that I need. So we've got a TL072, right here. And we have an MCP 6004. Oh, and I need 2 other voltage sources because all of this, whatchamacallit? Chewy, chocolatey, crunchy Hershey's. Oh God, I am not immune to propaganda in the form of advertising. Okay, we need MCP 6004. MCP 6004 is a low voltage low voltage op amp that only goes up to 3.3 volts. I think it might also work with 5 volts. I haven't looked at the voltage ratings lately, but this is a key component in the protection of our precious little baby. Our precious little baby boy here, our perfect little precious baby boy, only goes up to 3 volts. And if you give it more than that, it explodes. But this is a $5 microcontroller platform. The RP2040 is an incredibly capable chip. In fact, when it's in the Seed Studio Zhao form, it can go up to 133 megahertz. So there is a lot of potential in this circuit there, in this chip right here. And I got a bunch of these. So I'm going to turn this into a display module because there's a limited number of analog inputs on this. You have 3, and we only need 2, given that I would like to do my bypass scheme of the filter. So what I want to do, although there might be some ringing through the filter that comes back out, on the high Z input at the very end of this circuit that we have receiving all of our stuff, this thing right here, this abomination to mankind, both as an affront to morality and the laws of the land, we have a 9 kilohertz low pass filter that's getting rid of some higher frequencies. Now we can get rid of some higher frequencies by just having a feedback capacitor on the op amp. So I need to explore that a little bit. But a 9 kilohertz bandpass filter, that can be enabled and disabled by pulling this pin low. Instead, what I'm thinking is we just run this circuit over to another analog input so that we just take from this one or this one, depending on whether or not we want that filter in there. Yeah, the Hajiwo circuits are functional, and this is something that's done in microcontrollers. It's done because it's so part-friendly, it's so few parts, and it does such a great job protecting things, but I don't like it. I don't like it. So what I do is I do the mutable instruments method of having an MCP 6002, and it is only up to 3 volts here. So what this does is this limits it from 0 to 3.3, 0 to VCC minus a little bit. But then I'm curious. This is mostly settling my curiosity. This is very little to do with the rest of the circuit that I'm trying to design, and more to do with my curiosity about timbre and what the hell that is. And I think it has to do with this feedback component of this part of the circuit. You guys want to just look at the circuit. This is the circuit. If you're hardcore, maybe you want to take a screenshot. This is in my stream project section, actually. I know, make the jokes. Make all those jokes. My dog is barking her head off right now. I mean, I could, every time I say it, I could go, timber, but I really don't want to. I don't want to do that to my voice. I didn't stream yesterday because I had to pick things up and put them back down again for old people and drive places. It was kind of a hectic day. Today is too, though. Today's no exception. Okay, so MCP 6002 we have. Now there's 2 more boards that I want to make. One of them is a negative 10 volt supply, and the other one is an LM1117. Somebody has replied to that circuit post. What, in stream projects? Oh boy. Oh, it's been Gizmo. I'm going to ignore it. I'm not going to look at that right now. I don't want the answer. So, all right. I don't want the answer. I'm not looking for the answer. I'm looking for the answer, not you. I do not need a smarty pants McAnswer buddy on this channel. I don't need it. What was I getting? Oh, I was getting my circuity thingies. So I need, oh, but that's in what bin is that? That's in one of these. Okay. Gotta remember where my stuff is. Part of a shop like this is knowing where everything is. So I need something in order to hold that negative 10 reference. All right, don't remote pilot me. Oh my God. You have to know by now that the least motivating thing somebody can do is tell you what you're about to do. This would be good for the big power supply, but I don't need the big power supply. Have I already done this before? I may have already done this before. You laugh every time, but I correct you every time too. Stop doing it. Stop making me correct you. I'm getting angry. I'm angry. We want the LM1117 because that's going to eventually be the same supply that we're going to use in the design anyway. So I have a feeling this is the. Oh no, that's a two. I've labeled it. It's a 2222. Oh, it's useful. Glad I labeled that one. Another 222. Ooh, this one might be an LM1117. Let's see what it is. It'll be good if I already have boards for this stuff. Boy, you can really barely read that, huh? Whoa! 1117 3.3. Okay, this is exactly what I need for that. That one goes up here. That's our 3v3 supply. And now I need a -10 reference, and I'm not sure that I have a board here that I've created that does that -10. So, yeah, I don't think I have that. I just don't think I have that. What's this one? 3904. Oh, that's for the trigger circuit. Don't need that at the moment. All right, so I'm going to have to make a -10 volt reference, which requires a couple different pieces. Oh, that needs to go back. Need to make sure things go back to where they belong, otherwise I'll never find them again. Let's bring you guys over to here. You can see stuff a little bit better. Yeah, that was what Short Lurker wanted to do. Let's put the spoilers on, but I think that front one isn't diverting air upwards. It's sort of, I don't know. It's just sort of a front bumper. That'll probably explode the second it hits something, but I'm more interested in the very, very soft rubber tires that I've got on the thing, providing me with grip. Because I drove it around the floor in here, and it was very, very grippy. So, okay, so what I need is an SOT23, but it's going to require a couple little extra things. But I think starting with an SOT23 TO236. Well, if this one's an SOT23, maybe I can hook up the back of this in order to create all the voltage I need. I just don't think narrow wheels mean better steering. Yeah. Well, so it's degrees bricks is how you measure the softness of rubber, and the degrees bricks that I have on that thing, on the wheels that are shown in the latest picture, are 5 degrees, which is very, 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 very soft. It's like chewing gum. And if you put the chewing gum wheels against each other, there's a chance that they might weld together. The rubber might just connect itself. The other thing about it is that, oh shit, that's the wrong focus. There we go. The thing about racing around with those is that they're gonna, first of all, they're gonna pick up any dirt that they find, and in addition to that, they are going to end up wearing themselves down very quickly. So I'm interested to see what they do. I got the super soft ones because I thought it would be funny. So what part do I need? I'm not attaching a scalpel to the RC car. That would be dangerous. Very, very dangerous. The thing is already, like, could probably break your ankle, so. All right, so we're only using positive and negative 12 volts, and so we need the LM4040B10 in order to make -10 volts. We will hook that up to -12 volts and a 330 ohm resistor. So I need to put this together. I guess there are 1, 2, 3 pins to this thing, although 2 of them are for this and the LM4040B10. LM4040B10. Depiction of violence is also tossed. Well, that invalidates most of my clips then, because there's a lot of old clips that are from the day we hooked up the tank to a knife. What are pinout? All right, so that's the pinout of this thing. So I've got a couple of these left. Hopefully I have enough to build all these circuits. So we're looking for the LM4040B10. 23, 16 SOIC, my F beads, none of these. PFET, nah. 414/8, no. I'm going to try to stay through hole with this so it's a little bit more accessible, but some of the parts we can't get otherwise. Yeah, but like if you point a gun at chat, I think that's toss. Or no, what was it? It was when you shoot a gun, isn't that toss? It's all the people that had a negligent discharge on camera. We asked about cleaning guns, and we didn't really get a good answer on that. Which probably means whoever sees it will have a different impression of whether or not it's toss. I'm not going to let you guys lecture me on toss. I've read all the documents, at least as they existed a couple of years ago. Lynn's stuff. We're looking for the LM4040. How am I lucking out on all these? There it is. I got a bunch of them left. Good. Thought I'd be running out. I also have a 2.5 volt reference just in case we need to do that offset 2.5 voltage somehow. Yeah, and I've also got a 5 volt version. Here's a different 2.5 volt. Although for this one it would be 1.6 volts, so that doesn't actually work. I'd need to just voltage divide the VCC in order to make that 2.5 volt offset. Which is why I was hoping to be able to do that with like some other mechanism, but not sure. I'm opening a soda. I opened a soda. Okay, so we got this little guy right here. We're gonna connect him over here. Oop. And then we have to provide it with the support stuff. All the support stuff that I could possibly eat. Maybe this would be better to build on a perforated prototyping board since, yeah, this would be better to build on a perforated prototyping board. This thing sucks. Get out of here. Let's take this and let's make a little 3-pin adapter out of it. Actually, there's not enough meat left on this one. Oh, this doesn't have to be big. I could use those bottom 3 pins, but let's take a different piece of circuit board. I'll hold on to this one just in case it comes in handy later. It won't. It'll never come in handy. I don't need a 2.5 volt reference. I need a 1.6 volt reference. Since our offsets are different. I think. 2.5 volts being half of 5 volts. Now, have I cut anything that's 3 pins wide and clean enough to use? There's probably a little piece of scrap at the bottom of this thing that I can use. No, like if I needed a 2.5 volt reference, I'd use one of the LM4040s that I have. There's no, what's the point of doing it another way? Oh, I wasn't paying attention. It's gonna be the next reply, right? You guys answer stuff without paying attention to what I'm actually trying to accomplish here. Okay, I have nothing that's 3 holes wide. Oh man. All right, we'll use this little scrap right here. This little scrap right here. Oh god, I dumped everything in the wrong direction. This one's not bad either. Let's use this one. I got these boards with this perforated prototyping board that has an ESP8266 set of footprints on it. Not as useful as you think they'd be. Not nearly as useful as you think they'd be. Okay, so I need 3 pins wide because we have 3 pins involved in the circuit, right? -12, -10 out, ground. So -12 in, ground, -10 out. And I'll have to make a label for this once we get it all together. So let me reduce this to 3 pins wide. And what does the circuit look like? We have the 2 ends of the pin there. We have 100 nanofarad that goes across it. That's from ground to output. And then we have a 330 to input. This is going to be very tiny. This is going to be very, very small indeed. Maybe I should go... Well, I've already kind of made a cut. All right, I'll just do this. And then I need room for a label, so I'll take it like way up here. That way I'll have room to put a little label on it. And it's basically going to be, it's not even going to be that tall. That's crazy. All right, so I need a 3-pin right angle header. So this, I hit my head. So that this thing can stick up. Let me get these away. Out of my sight. I should probably untrapezoid this thing a little bit, which means getting a file and just running it a couple times on the file. I'm trying to reduce the amount of filing on stream because it's kind of boring. Everybody's seen it before. But, you know, making your circuit board pretty is it's an important facet of this. Those are kind of thin, but that'll be okay. All right, so this is a much better platform for us to build on. Let me get that 3-pin header in there. Now, these are the really annoying ones, but I guess I'll use them. I don't like these because they bend after the connector. So they don't sit as cleanly on these boards. They sit kind of in a weird way, pushing the thing back a little bit. But I don't know, it'll be all right. It doesn't do that much. I've never had a fiberglass strand go into my finger directly from a circuit board. Put this one all the way down here. Why am I unable to do this? There you go. It's like, what's wrong with me? All right, so the way to do these right angle ones is just to knock this into the perforated prototyping board so that everything gets, solderless breadboard, so that everything gets held in place, and then just straighten it out by hand on one single, damn it. Where is my focus point? There we go. So I'm just going to hold... Wait, why is that one huge too? Wait a sec. What happened here? It shouldn't be that big. Something like changed all the sizing for my... Oh, well, no, wait, this is the... Hold on, wait, Control-Z that. This is supposed to be zoomed in because this is the face scan. That's right. I zoomed that one in intentionally. I intentionally did that. Wrong, just to test you. Okay, so anyway, I'm going to solder one of these pins and then hold the thing at a 90-degree angle, and then that'll attach everybody. Pretty good. Okay. Copper cuts. Yeah, I don't know. I usually file the circuit boards to keep them smooth, but even on the ones where I've cut across the holes, I've brushed my hands against them, and they're not as bad as, for instance, through-hole parts. Through-hole parts will tear you up. Tear you up. Get tore up. Okay, so there's the beginnings of our negative 10 volt reference. Now, I put this thing in here. And I can do two components that'll go across. Well, actually, if negative 10 output is in the middle, I guess that's okay. I'll just have to label them. Because minus 12 and the 330, and then the LM4040, it goes across the two pins, and then I'll have a capacitor there. So if I just have 3 tracks going up, it can be capacitor, LM4040, 330, and that's it. And then it'll be ground, negative 10, negative 12. Unfortunately, I can't do the in, ground, out, but I do have enough room up here for a big label on the whole thing, so that'll help me sort it out. So the LM4040, the expensive voltage reference chip, but it's a nice voltage reference because it keeps things nice and stable, and I'm not even going to solder that center pin. Willow is doing better and better in my mind. Some people aren't seeing it. Some people don't see it in the household, but I do. I think she's been a lot more active than she has been. It's a rainy day today, so she's, of course, a little bit mopey, but I think she has been much more active lately. She's on the road. She's on the road to recovery. Do I want to spread out with this, or do I want to jam the whole thing? I think I want to spread out just a little bit. I want to keep things separate here. So I'm going to put this up here, even though I could put it much further down and just cram everything together. Oh, what is the direction of, hold on a sec. This thing has directionality, so I got to make sure that's the right way. So I want the bottom pin to be ground. And it is the opposite way. Connected to anode or left open. Why did it switch to... I moused over one of the other things. I clicked on that and then I moused over something and it switched windows for me. So pin 1 is actually going to ground. Okay, no, that is correct. Then this is in the right way. Yeah. Okay, yeah, this is correct. Good. So then I just need to find 100 nanofarad is 0.1 UF, right? Yeah, so I just need to grab a 0.1 UF somewhere, which are easy enough to find. I think they're in the capacitor bins, though. So let me go find one. And then I'll need a 330 ohm resistor, which is also easy to find. There's the kilo ohms. Dig deeper. More greedily. Faster, more intensity. Let's see. Picofarad. Okay, so here's 0.1 UF. 0.1. 10. No, there's 0.1. I have a billion of these because, you know, you order these by the bushel. Of course, I also have a lot of them in other capacitor things. Like, these are huge, the ones that are in this one. Oh, wait, those are the 1206s, and these are 0805s. Actually, can I get away with 1206 here? Using a nice big capacitor, because I don't have any other opportunities to use these. Oh my god, it's enormous. That would actually work. It's a little bit much, but this is only a 0.1 UF. It just happens to be in 1206 flavor. It's a little bit much. Actually, because I have to fit a resistor there too, that's not really going to work. I'm going to go with 0805 sized. And the capacitors, by the way, are not 1206 and 0805. I just equate them to the near enough as makes no difference size. So sometimes you'll see people doing that in their designs. They will call a capacitor like 1206 and 0805, but there are actually different designations for caps. They have completely different schemes because the capacitor is limited. The capacitor size is limited by physics, not you know, whatever else. 330. These are K. All right, hold on. Got to go deeper and deeper into the bins here. $330. $330. There you go. Plenty of them. Plenty of them. I need to order some resistors in the near future here. Those just go like that. This goes here, this goes all the way up to there, this goes all the way up to there, and that's our negative voltage supply. Very easy. Simple, simple, easy, easy. Could have made it smaller, didn't. I gotta put the bins away so I don't knock them over. If I knock over these bins, it's an international disaster, and I have to call like UNICEF to help me clean up. Okay, so 5 to 10 pin connectors solder stations use are called. No, they're all going to be different, aren't they? Or is there a standardization that I don't know about? It could be a type of radio connector. If you're talking about the connector that I think you are, I think it originated from radio handsets. But like my solder station is a different connection from like a Mitutoyo or whatever. Not Mitutoyo, who's that? Hako is another one. All those manufacturers use different standards. I thought. Could be wrong. Why did you turn off, you stupid soldering iron? Piece of shit. Okay. That one in there. This one in there. DIN? Is that? I thought DIN was a rail standard. That's different. Yeah, I think if you're talking about what I think you're talking about, it is a radio handset type of connector. So you might want to start there. And maybe if you get a result for radio handset connector, it'll say specifically what it is, and then you can look out, you can branch out from there. DIN but more robust, huh? Well, thank you, Anthony Den. All right, so this is our negative 10 volt supply. I just need to get a couple. Oh, actually, I got a couple pins right here that are left over from cutting stuff, so I'll just use these. That's the fun part about having parts strewn all over. If I had some kind of a first-time chatter notification on YouTube, it would be pretty much every single chat message would be a first-time chatter. We get like 2 people from YouTube watching, which is great, and I'm glad to be branching out. That VOD channel is not quite doing gangbusters. But I guess it's not about the numbers. It's about having the content. Yeah, I'm seeing more and more people, though. It's slowly gaining traction. There was a time when YouTube had, I had like 500 views on one video, because I think YouTube, if you do daily uploads, YouTube will give you one chance. They're like, here's your one chance, kid. I hope you make it. And then I didn't. People are like, I keep seeing this feed. What is this? Well, these are VODs from my live streaming channel, so they're going to be 5-hour videos. I hope you're in for the long haul. The DIN connector is German, but I could be wrong. Oh, okay. Well, that would make sense. I'm familiar with them from radio handsets, unless we're talking about something different, which we could be. I'm talking about the one that screws in and has sort of a semicircle with a little nub in it. I don't know if my soldering iron, my ADS-200 does that, the paste station that I have. This is going to be a tough one to solder because I want everything to solder at once, and then, yeah, surface tension. God damn it. This is why doing the little wires is easier. The wire wrap wire, where'd it go? Do the farts work on YouTube? No, I don't know if there's something that I can hook up to YouTube for that. I have decided on what node I'm going to install to do that, and we just need to work with it. And I think maybe I need to work with it one day because it involves a lot of the secret codes for like registering a robot and stuff on Twitch. But that would mean that I have one front end for all of my interactivity stuff, so I can enhance things. I could have the piss box too. You guys aren't going to get a piss box, all right? Just don't. Let's temper that expectation. Although I've mentioned it, you're not going to get it. Nope, temper that. You guys are already spoiled. With or without a piss box. Mom found the piss drawer. What the? All right, now for the label. Let me just solder that up a little bit more. I want this pin to move, though. I'll just add solder on top of it. You saw this chart yesterday. Yeah, one of the 10,000. Something can be on the internet for ages and ages, and not everybody has to see everything immediately. Sometimes you find somebody who learns about something for the first time. That makes them special. Usually, though, people loathe things like that because they're like, this is a repost. And it's like, people are not as terminally online as you are. Okay, we need a label on this thing. We don't have a lot of room to label it. So, belabel label. Let me get my labeler out. Where did I put it? Oh, all the way down here. Here we go. There are newer versions of this that you can recharge, and I would suggest you get one because every single time this fucking thing runs out of batteries, I am out 5 AAAs, or yeah, I think 5 or 6. I think there's 2 under these. And there is a battery pack that you can put in this thing, but it's like, I don't know. Just get the updated one. This one's old. And I have 2 of these things too. I was putting all the information for my D-Link repeaters up. I have the Dymo that uses 6 AAAs. This is AA's at least. That's a little merciful. But they still run out in no time. But having a digital labeler is amazing. It's possibly one of the better things that you can get for the shop. LM 4040-10. Well, it's actually probably -10. And I want that in 6-point font. So I hit the size button. That's 6-point. Line 2. Now I got to figure this one out. Ground, -10, -12. So G, capital G, G. I don't know if I should put the minus in there because that's 3 characters. -12. And let's just see how that works out. If we can fit that on the head of a pin. I got the €20 version. Well, you mean the one that you like punch through the piece of plastic? That ain't gonna fit. I might make it fit. I might be able to make it fit. Let's cut away all the excess and just see. I gotta cut it real close. Like that. It would be very nice if I could actually get this to fit. Oh, those are lowercase letters. That looks a little awkward. That's a little awkward. That's a little cringe. But at least with the digital label, the printed label, these colors don't run when you handle it with finger grease. Well, G minus 10 minus 12. So, oh wait, what the hell? apparently this is sticking up in the air. How far is it sticking up? Not much. You just push down on it. I think I'm just going to cut off that 10 because the minus 10 is already there. It burns like that, but just much smaller. I don't think my eyes could take any smaller than this. I don't think I could handle that. No, I do kind of want to upgrade to the brother labeler or the Dymo or whatever of the more recent, the one with the lithium ion battery, but there's no point. There's no point. I already have something that's good enough. Do this as low as possible. And then cut off the excess up top. Or do I put it all the way at the top? Now we'll just put it right there like that. It'll be LM4040 minus 1, it's going to look like. Press down on that. Just get that on there, and then cut this going downwards against the label so that the unsupported part butts up against the edge and cuts. And there we go. Uh-oh, no, don't cover that over. That's good enough. You guys can see it from there. Nice and blurry. Bada bing, and it's all crooked. Perfect. So that would be our negative 10 volt supply. So we give it negative 12, we give it ground, and it produces a voltage out of the center pin, which is kind of weird. It's kind of annoying, but that's just how it is. That's just how it's going to be. And that top pin is floating because it's supposed to be. It's a little sloppy, but it should be fine for our purposes. So now we have all of our voltages stuff. We have our 3.3 volts. We have our negative 10 volts, which is negative 10 volts is a little awkward, but okay. It takes up an entire row. God, that sucks. So yeah, there we go. How come that one is so much tighter? I guess it's not. Weird. Put the knife away. Get all these scraps off of the board. Get the solder out of here because we're not going to need solder. Wire cutters we might need, but as long as things are where I usually keep them, we'll be able to get them again. A place for everything and everything in its place. Oh. All right, and then scissors. I get all the blades off of the desk first. Then I get all the sharp electronics off of the desk. Then I can wipe my palm across without perforating it in order to get all the garbage off of the desk. I'm just going to throw away the remainder of this. I don't care if you guys would use it. I'm not. No, you can't have it. We don't need the labeler anymore. Turn that off. Using labeler to start labeling out all of the internet stuff that I've got going on here, including the repeaters that I have upstairs. Those things are so necessary. I don't know what they did when they built this house, but they did something in the walls. There's something in the walls, and it's not grandma. What happens is these Wi-Fi signals, they don't permeate the house. Maybe it's mostly because the internet equipment is all in the basement. I don't know what these companies are thinking. Maybe that they're going to drive sales, but like the internet comes in, the cable from the fiber optics go to a box outside, I believe, unless it's just regular cable to like the whole neighborhood. Either way, what comes into the house is coaxial cable. There's a lot of copper on it. They can get a lot of information to and fro that copper, but that copper comes into the house in the basement because typically, at least in the 90s and before, you would drop all those wires down to the basement and then they would all go to like a central location where everything comes in. And so that was the natural place to put the cable box. And these companies were like, well, why don't we make it into a wireless router too? what a great idea. And so what happened was all of the wireless router stuff is in the basement, and they don't give you special antenna to try to pump those signals up through the rest of the house. They don't give you any type of a repeater that you can use. They sell them now. I'm going to burp. They sell them now, which means you can run an Ethernet wire up to the repeater and then repeat your wireless signal. But like, I don't know, they just never consider this stuff. They figure all of these people designing this equipment, and I guess it's probably the most common denominator that you can get across the people who are now getting cable, because there's a lot of new people getting cable that don't necessarily have this stuff installed in their house, but they will have the cable wire come in and go to like their desk, which is on the top floor. Right? They have it come in, and then so in all the documentation for these devices, they have the home computer, the one home computer, and then the Verizon like super duper cable modem sitting right next to it. And that broadcasts wireless out to everybody's devices from a floor that isn't in a basement where the ground is going to absorb all the RF energy. It's been a little while for the fart box, Niano. It'll come back. I need to build up the Node-RED front end. And I've found a project that I think will be good for a Node-RED front end. It's not a tragedy. Shut the fuck up. It'll be fine. You're going to get your fart box back. I've just taken it down for a little bit. It's not like Burn the Subs. It's a much less comprehensive project, and it also paves the way for much greater functionality, including Burn the Subs. So just bear with me a little bit. You guys are so bad at waiting for stuff. It's working on these projects is tough, man. I put a lot of work into being competent at these things, and it's not often the case. And usually some chat member will come in and pull the fucking rug out from under me when I'm just starting to get to the point where I can relatably get to the part where you understand what's going on. That's the important part of this stream, and I don't know if you guys know how much work that I fucking put into this, making sure that I can be relatable to the point where things can be explained in plain language. And what that means is that we have to slowly develop some things, and it's tough. That's tough too, because I need to keep this a punchy stream. I need to keep this punchy, and I haven't been very punchy. If I was faking a lot of it more and I had like a staff, maybe I could have them come up with some of the stuff, and I would seem like I'm just naturally falling upon all the right answers. But I like to show things my own way, and I'm just a one-man operation. I got to run this accordion. I got to run the cymbals. I've got to you know, play the drums at the same time. I got to juggle. What is this circuit doing? I have no idea. I've done a little bit of equation work on it, and there's some kind of a feedback that I think is creating timbre here. We've got what I'm trying to do is essentially create a gain adjustment circuit that then goes to a 3-volt microcontroller, and this is one of the circuits that I wanted to look at and test. I don't think it does what I needed to do, but it's a nice little intro to the complexity of some of these systems that I might run into later on in the synthesizer build. So as audio comes in here, it is getting put through an inverting op amp. The inverting op amp is tuning it from 1 to 49.9, and I believe that's, or 1 to 4.99 or whatever. Hey, Nano Cat, thank you so much for subbing. That's 9 months. Hey, I really appreciate that. Yeah, my guest writers, my underwriters. We're good at waiting for stuff. You can have us as staff. So yeah, we've got a 100 kilo ohm and 49.9 op amp going on here, inverting op amp. But we have another signal that would get inverted, and it would get biased by the modulation control here. This 10 kilo ohm potentiometer is also sending that audio signal into a 124.9, you know, whatever the op amp equation is over here. So that is then getting mixed. This one gets 24.9 on this side. So it's 24.9, 49.9, and whatever's 100, whatever's left of 10, 49.9, and then negative 10 volts to 0 volts, 200, 49.9. And that of course limits it. The math basically brings it to the appropriate numbers. This is crazy. What module is this from? Oh, God, I don't know. I forget which one it is. It's It's the wave shaper one. Whichever one is the wave shaper, that's where it comes from. So that's what I can glean from this circuit, is that that's happening there. The part that I don't know how to math for is this feedback, because this is a 10K resistor, but it goes into the negative here, and it goes into, or it comes from the output here. So from the output there's another loop. It's actually a loop like that. Weird. So this is very confusing to me. And instead of trying to figure out how to get this mathematically, I am going to go through and build it and figure out what kind of stuff we see on either end when we give this thing something like a sine wave. That's the plan. I don't know where I'm going to get 24.9 and 49.9. I might just have to double up on the resistors. So let us get started. Now that I've put all this stuff together, we've got all the things we're going to need in order to build this, and we'll do positive 12, minus 12, and then the inners are going to be grounds. So I'm just going to go ahead and put, put this here and here. Those are going to be our ground. Actually, I should use flat for this. Let me get a kit, one of the wiring kits for these things. We're going to use the crusty one. I guess we're going to use the crusty one. What up, Pyro? How you going? All right, let's see here. So I need something that's going to go from one side to the other. The lengths of these things are always so annoying. They're never quite right. Yeah, I guess that'll do. So, you know, I meant to be working on Burn the Subs, but I got distracted by synthesizer stuff again, and we're working on building up a circuit for Immutables Instruments, John, that I can use in order to build a display module. Display module should be pretty cool. This one's all messed up. This the headers on this one are all messed up. I'm doing fine. Great, even. Okay, so we have our 3 volts here. 3 volts is going to be for the MCP 6004, so we probably won't need it until later on. Our inputs are over here, so we can do inputs over here. We can put this op amp. This is the, wait, this one's the, that's the MCP. So the first one we hit is TL072, which is here. And then our TL072, we've already got the pinout open. The TL072 pinout is in this window. You don't need you. That's Hajuo. So plus is on pin 8. VCC is on pin 4. So 1, 2, 3, 4. So we're gonna go like this. Flip it around so that pin 1 is here. Now these are made for dip packages. Oh, did they do the same thing that they did here, where they made the payouts for those lotteries much, much larger than they used to be? Because that's what we have here, and every couple months, people are like, "You got to buy a lottery ticket," and I'm like, I could also probably have more chance to get hit by a car, like, and I'd probably have more fun getting hit by a car. Can't win if you don't play. You can't win if you do play. I mean, come on. Let's be realistic here. That's ground. I need this to go to plus, so I need something a little longer than that. That would probably be the orange one. Orange is too big. Yeah. Let me get another kit. This kit is very frustrating. I've been frustrated with this kit for years. I finally just forked up the $10 to buy a couple more. They're not expensive. You just buy more. Consume! Fill the landfill. All right, this one's plus. Pin 8. That goes all the way over to here. Even that one doesn't make the span. Is there a slightly longer one? These always have a big jump in the sizes, don't they? Green will probably do. Oh man, can you believe people are gambling so much? Like, they opened up a thing for like sports bets, and now everybody has like an app on their phone that's doing sports bets, and they're like, yeah, it's cool, man, I'm not really doing much. There was a post I saw on Reddit where somebody made $30,000 doing sports bets, and they feel like they are the ones who are benefiting from this because they've got a slight amount of like knowledge into the betting, but yet if you break it all down, you're still losing tons of money on these things. They never talk about how much you're losing, and it's like, oh god, it just bugs me to no end. It's like, for a while we had like bans on gambling and stuff like that, and now we're just letting it all back in. All these scumbag fucking apps are addicting a new generation of gamblers. And it bugs me as somebody who knows a little bit of psychology and how viscerally addictive it is. The lottery is a tax on people who don't know math. Yeah, I mean, that would be for somebody who constantly plays the lottery throughout their life. I mean, you play if you play every now and then, you're like, this is a big number, I'll play the lottery. You're never going to win, but if you have fun thinking about what you could possibly buy with the winnings from your $1 billion winnings from the lottery, maybe you've gotten your $1 ticket's worth. But otherwise, yeah, it's just a tax on people who don't know math, who don't know the utterly staggering, incredible numbers that are involved in statistics. Good old statistics. What are pinout of this thing? Oh, it's labeled ground out VN. So ground out VN. So we're doing, I'll hook this up somewhere around here. Get another green one. And then the center one is going to be ground. So I'll do ground there. Well, ground out in, so this would be the VN. I'll get the yellow one here that I discarded as ground. Have you ever seen these commercials on TV? I've been hanging out with my folks a lot lately just because of all the stuff that's been going on here, and they watch a lot of TV, and they shouldn't, because it's brain rot. It really is brain rot. It really, really is brain rot. But in so observing of their brain rotting, I've seen a lot of these ads, and they show like all these wonderful, colorful lights and these beautiful women smiling ear to ear at the fact that they're winning in the lottery, and it's bad. This is like bottom of the line kind of manipulation. MCP 6004. Let's hook this thing up to power too. MCP 6004. This is actually 6002, but this is the same. It's the same thing. Let's look at that pinout. Datasheet. I don't want to download it. Okay, it just opens it. See, this is a good way to do it. That's a nice way to show it. 6002, VDD and VSS. So our positive is pin 8. It's just like the TLS72. It's just much lower voltage. So we flip this one around too, and we give it plenty of breathing room. I don't even know what the circuit's supposed to look like yet. I'm not Moritz Klein. I don't know everything. I don't have this planned. Why did you think I have a plan? That's 3 volts right there. 3v3 right here. Actually, I'm going to move this up one. The Moritz Klein videos are so good. He does such a great job of showing why all of the different things are chosen in a circuit. The only thing I think that's lacking are those diodes, the capacitors that they pepper designs with. They pepper the designs, Angus, with capacitors. Hey, look, it bears repeating, right? Actually, you know what? This would be better up above. I'm going to move this up. Move the voltage regulator down and have this up here. That way it's all laid out nice and easy and clear. And then ground on that one. Look, I run a tight ship when it comes to breadboarding. I don't like there to be anything out of communication on these things. And I like all my parts to be tight to the board, because if you have to transport it, or if you want to put it somewhere for a little bit, all your parts don't get smushed or pulled out. Yeah, the sports betting thing, you never know how much these people spent. Because they don't tell you. They go, I won $10,000 once. And it's like, yeah, but after how many years of doing that? How many years were you betting on sports in order to do that? Just because you think you know a little bit about how people throw a football around. I'm waiting for all the inevitable, like, manipulation lawsuits and stuff like that. I think this one is the one that gets the -10 source, right? Let's check. Well, the -10 gets -12, so I might as well put it on the other part of the board. This one does not. Oh, yeah, here it is. Yeah, it's the second one that gets it. Okay, so I'll put that down here over on this side, and I'll put it all the way up here like this. Actually, it'll be better if I leave a row of holes above it. And then I've got ground and 12, ground and -12. So ground will get one of these. Come on. Go, ground, and then a green for -12. Come on, damn it. You stupid thing. -12, okay. I just had nightmares imagining somebody using hot glue to keep the breadboard together. I've seen stuff like that. Some people have installed breadboards in their final edition of the project. I mean, there's nothing wrong with a little bit of hot glue. It just takes a splash of alcohol to loosen it up. I mean, that applies to me too, but you know what I mean. Are these off? These seem off. It seems like I didn't press them down enough to solder them in. No, they're fine. Okay, two 10K ohm potentiometers, an input and an output, or I could just do output through wires. Let's see. So what do I want to do? I want to take... well, we build the circuit as it is, which involves a 10K ohm there, and then an AREF gets the 10K ohm. So let's start on one end and just build it over. So what we've got is on the pin connection, we have ground and then a 10 kilo ohm. So let's get ground over to the pin connection. It's got to be much longer than that. Better I move this whole thing down, but I think it's probably better to have it like this. So ground goes all the way up to, I think that's the switched connection. And then ground goes to, oh no, wait a minute. No, it's this extra little pin down here is ground. So that's ground. Ground. Let's always get grounds. I'll get another one on the second one. Could probably print labels for that, but I don't think that would be too useful. All right, so those are the grounds for the in and the out. I guess I'll treat these as in and out, because then I can plug in the O-scope adapter for the output. And then which one is which on this? This one goes down to here, and that would be, is that the clip? Yeah, it is. So the one in the middle gets disconnected, and the bottom one is the input. So this bottom one here gets a 100 kilo ohm resistor and then goes over to the knob, the first knob, and that's on the common pin. So I'm going to need an extremely long one. But not that extremely long. Although I do kind of want to avoid stuff, so maybe I'll come up and around with it. And then that one's going to be the one that's next, or one down from there. So if I go like this. Nope, not quite. Maybe if I go directly out of this. So I like to keep a row above where all the pins are. That is kind of going to get away, blah, blah, blah. That is going to kind of get in the way of some of my power connections, but I think I should be able to work around it. I don't really think people need that in their life. Oh, wait, I have a 100 kilo ohm resistor that it also has to go to. So let's pop this thing out a little bit. Oh, let me get this back over here. I can't even imagine finding meaning in life in sports betting. What the heck? Why is this thing fighting me at every turn? Why are you fighting me? Stop fighting me. Got it in here once. I guess there's only like a couple of positions that it fits in. Oh, I think there's a stiff pin over here. That's why. Ooh, made a popping noise. Strange. Okay, so 100 kilo ohms. Resistors, through-hole resistors. These things are annoying. I don't know where to buy precision resistors that aren't this size, but the problem with these is that they barely fit into the breadboard because they're so small. So it's a 100K, and I'll make that a short run. I'll just move it over to the side there. Oh, whoops, it's coming from over here. Wait, let me turn it around. Oh, these aren't supposed to go there. These go over here. And then these go over here. That's why I was having trouble. Okay, so this one gets 100K. Bring that over to a random spot. And then all I need is for this one to go to there. And I guess I can do that from behind there. Here. Pack this thing down like that. Just get it out of the way so it's not going to get in the way of my other circuit running stuff. So now we have 100K to the potentiometer. Open up MS Paint. So now we need a connection to both the TLO74 and the MCP 6004. Am I up to date on all messages? I am. Okay, so from the 10K, we're going two places. Positive of the pot goes to, or sorry, of the op amp goes to ground. We're making this 1-for-1, so this is just a 1-for-1 recreation of this circuit. So what I'm going to do is pull up. Let me just pull up that page that has the MCP pin out. Put that way over here. And so the op amp that I'm using, I guess, should be probably. We'll just use this one on top. This one over here, rather. And then. Oh, I didn't. -10 doesn't go directly into the MCP. Oh, this is. No. No. That's very wrong. No. Ground. Oh, wait, no, that's correct. This is 3.3 volts. I am the wiener. Yeah, that's 3 volts. So this gets 3 volts, but then our input goes to a 100K into here, and then I don't know which direction it's supposed to be. There's an arrow on it. Mutables puts a little arrow on the pot just to tell you which one's which, but what? TLO8 and TLO7 is the same die? Weird. So one of these goes to this one, the other one goes to the other one. So I guess I'm just going to do the near one goes here, the far one goes here. And so here's the one that goes up and around with no other components in the way, and it goes into the negative, the inverting input of the op amp. And then the positive, or the positive goes to ground. So the positive on both of these goes to ground, and that would be the pin right near VSS. Wait, that's VDD. VSS is ground. Did I do this one wrong? Double check my work. Wait, that one is VSS. Okay, VSS is ground, so I did this upside down. So if I flip this one, then 1, 2, 3, 4. Wait a minute. No, this is correct. This is correct. This is correct. I'm looking at the wrong side. Because this is pin 8, VDD, which goes to positive. And then output minus plus, so this pin goes to ground. Jeez, that was easy. So this one goes to ground. This little piggy went to market. Ah! You need tweezers to operate these things. And then one more, because the TLO74 also goes to ground. And that one, the TLO72 rather. TLO72's pinout is... Drum roll. Yeah, same thing. Pin 8 is plus, and then pin 2. Wait. Pin 6, right? Pin 5. 8765. And VCC minus. The opposite of VCC minus is plus, which is this one. This one goes to ground. There's a lot of, I mean, these solderless breadboards were practically built for op amps. You can make some very nice circuit structures, nice, neat and clean circuit structures on these when working with op amps. Okay, so that means that, and we're still in the middle of this thing. I've only one resistor down so far. So the next connections that I'm going to make are here to here. So I don't know which end the arrow. I'm going to put the arrow on the right side of the potentiometer. Maybe that'll just work out. So from here, I have to go to this pin right here. Here to here. That's not that bad. We can probably do that behind the thing since it's a little bit awkward to see. Or I could do just straight over. Yeah, we'll just go straight over because that'll be a little bit more clear what's going on. The problem is the kit might not have quite that length that I'm looking for. And although I could do 2 jumps, I would rather make this just one big smooth jump, which makes it a little bit difficult. Yeah, there's like a gap in the distances that these kits go. I mean, you could just do this and then go up and over. Still way too much. It's way too much. There's gotta be something that does this. There just has to be. I don't think there is, though. Isn't that weird? I just don't have that ability to, I don't have the ability to go that distance, that short distance from here to here. There is no equivalent jumper in the kit. And it's like they don't really feel the need to do it. I guess I can go 2 jumps and hope I don't run into anything else. Go right next to that, and then I'll go shorter than that. Which there might not be. This is so ridiculous. It's ridiculous. Let's see. No, that's much shorter. I might actually do it. It did do it. Okay. There's that. That's for the input. There's 2 feedback elements, and that's going to be a resistor and capacitor. Although I could probably put the resistor very cleanly on there. And then output over here has to go to the input, the one that we just connected over here. And that's with a 24.9K. I don't have a 24.9K, but we might be able to make a 24.9K out of some of the resistors that I have. Let's see what we got. Now I do have surface mount in 24.9, I believe. This one's 10. That might come in handy. 4.7. Not labeled. 24.9. 33. 27. 22. No, that's 22 ohms. Wait a minute. No, I need 22K. I think I could do 22. And then, well, 24.9. That's not an easy one to do. .5, 5.6, 22, 33, 39. Yeah, 22 is as close as I get. 15. I'm not going to get 24.9. I think I might as well just put a surface mount resistor in a female header to make 24.9, and that's going to be, I believe, one of these over here that I have. These are those specific analog values. .39C, 39E. I don't think that's a specific value. .473, 4.7K. Or no, 47K. Ugh. Useless. I thought I got 24.9. I wonder if I've got it in these. I know I got this specific value. I've got like a bin of them somewhere. Oops. That's 24K. And then I could put a 900 ohm on that. Miscellaneous. No. Yeah, did I transfer them to a bin is the big question here. I know I have them. I don't know what happened to the reel of them. Maybe that's what the 37C ones are. Hold on. They could be specialty. So let's test one of them. Go. Let's test one. Oh, there they are. 24.9K. Okay, so that's what value this is. I'm going to need a couple of these. 1, 2. How many more? Maybe just 2. That one's 49. That one's 10. Yeah, I'm just going to need 2 of them, but I'll put them in headers, and that way I'll be able to use them with a breadboard. Surface mount parts, that is. Let me get this out of the way. Get some headers. If I was switching over to do audio projects more, I would probably want to buy some through holes of these values so that I could perf board them a little bit more easier. But this is my super duper technique for perf boarding surface mount resistors. If I can find the right header. I have plenty of these things. Where did that? Oh, here we go. This. Grab one of these. I've got an abundance of these because I kept trying to order a slightly larger size of these that accepted a larger pin, and I kept ordering the wrong thing. So I've got tons of these things sitting around. They come in handy for this, not much else. Not a whole lot else. So just need a couple 2-pins. And those just go on the perforated prototyping board. And they fit in pretty okay. They're not super loose, but they're a little bit to be desired. And then from there, what I do is use those as prototyping pads. So I will solder in. There's that resistor. Okay, I don't want to waste that one. I'll just put a bubble of solder on this. A big old booble. Another big old booble for this one too. I just take my resistor. Put that across the two. Quiet Friday, huh? Everybody's having a quiet day. I mean, I guess I didn't stream yesterday, so I'm effectively dead to the internet. Let me get another one of these. Make sure it's the right one. Was it the wrong one? Did it? Oh, it didn't drop. Okay. Oh. Where the hell? Okay. Sorry, I'm stuff is like flying all over the place because things are starting to layer up as I gather parts. Yeah, it's parts that I have an abundance of in the shop, and they go together and sort of make my prototyping stuff work a little better. It's like I don't want redundant parts for surface mount and through hole. I just want to be able to use what I use, and this helps me do that. It helps me translate the surface mount part into through hole. Now the other thing that does it are those little mini circuit kind of PCB adapters, but those are kind of expensive for what they used to be anyway, expensive for what they are. So while I could do this whole circuit surface mount and do it on a little platform, I bought some through hole stuff for some of the circuit building that we've done, so I might as well use it. But these specific values, you know, that are used in mutable instruments in my own designs are tough. So anyway, that resistor goes between the two op amps. So I'm gonna just place it like right here. This is a terrible placement. I thought it would go in a little better than that. Hold on. Get this out of the way. So I'm going to put this like right in the middle, and this one will go between the two. It gives me a lot more places to tap into either side of it. Maybe I should put this over here then. Yeah, it's just adorable little resistor adapters. I tried doing this sort of thing with the normal snap-off pin header, and it's not always nice with machine header like this. Yeah, well, the reason that I plug it into the prototyping board is so that it doesn't melt the pins and move them all around. And then I would do it with the stand-up headers, which works with 0603, but 0805 has to go from post to post, and that can get a little bit hinky with soldering it. I've overcome those challenges in the past, but then I got frustrated at it, and I was like, why don't I just do it with this? And this actually worked much better, so... Helps if you already know how to solder surface mount too. That's a dumb way to do it. Okay, where's the smaller one? There's one of those little blue guys that I was using before. Gone. Gone, like all the things that I care about. You don't trust breadboards. Well, it depends on the work you're doing. You know, we're not doing high frequency signal switching or anything like that. We're doing fairly good audio, but even then, we don't need the best breadboard. Some people would claim you do, but you don't. This would be from the output. Oh, wait, that's to the output. I need this to be from the going to the inverting input, which is this one here. Actually, I need a slightly larger jump than that. The yellow one was fine. There's our input resistor. Now I've got a bunch more connections that have to be made here. I'm almost tempted to move this out to over here, and then I'll have a ton of connections right where, but all of them are feedbacks, so they all come from the same place. I guess I've got here, 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 and here to work with. So this one goes back to the output. So this has to go a long distance all the way over here. It's going to block a lot of stuff. We will deal. As we have learned to do, we will deal with it. Ah, come on. It needs to be slightly longer than that. It should be this one. All of the way to here. There we go. So output from the TL07. Okay. Yeah. Wait, which one is connected to? Well then. Well then. I see how it is. I see how it is. And again, this is why you don't correct me when I'm making mistakes, because I fix mistakes. I ain't no YouTuber. I'll do everything perfect the first time. So we put together the whole system and it works. It's like, shut up. We're only going to need one of each of these op amps. And I think, what is the way to tie up unused op amps? I think you do output to negative so it doesn't cascade. Oh, my cursor's stuck. Not quite, not my tempo. What is this? A and B. They have positive to VDD and negative to VSS. Unused op amp in a quad package. This is a dual package. You configured as shown. These circuits prevent the output from toggling and causing crosstalk. Circuit A sets the op amp at its minimum noise gain. Blah, blah, blah. What about dual? They said in quad. We don't have a quad. Huh, I guess I'll just leave it alone then. We'll let it float. See if it does anything bad. Where's the other 2 point whatever K? So we got one of them. We got this one in, which goes between the two. The other one is the feedback for the TL074. So we go to the TL074, and between the output and the negative input, which goes output minus plus. So we just need to take this and just drop it right here. And just drop it. Just drop it right here. There we go. Is it soldered? Yeah, it's soldered. Okay. And then on the input side of that one, we're just going to run through the circuit, and it might be a little bit disorganized, but eventually we'll get to the point where everything starts to get hooked up. So the input, the negative input, the one that we just connected to, this one right here, goes all the way back to the bottom side of the potentiometer. So that goes all the way to here. And so there, I could use the super long red guy and go all the way into that pin, because we're going a pretty big distance. Back you guys out a little bit. I mean, we've got super long, slightly less super long, and really, really super long. Maybe we use slightly less really super long, and maybe that'll get us there. I don't know if that'll have it. This one won't have enough for me to avoid the rest of the stuff. Really, I could probably have put the potentiometers like here. I might have done a little better. But I'm committed. I'm committed to this circuit layout. I like to just fold those next to the board so that they sit like that. It's not the most organized thing in the world, but when you actually look at the top of the board like this, it kind of makes a little bit more sense. Although this one should probably go like out and around. I don't know. Okay, what else? So that'll conclude that side of the TL-074. It concludes the output side of the TL-074. So actually, we're pretty well along here. We've got this whole thing done. Like here, we've got that done. We just need to inject -10 from the other one. So let's get -10 to where it needs to be. -10 is over here. That's going to go to one leg of this, and it'll go to the opposite of the arrow leg, which will be the nearer one. So that goes from here to here. I need a shorter. Shorter. Maybe this one. Way too short. Well, it actually goes... Okay, so the wiper goes through a 200K. So that's fine. That's fine. I can do 2 jumps of a 100. I guess I'll have to use this. There's no in-between sizes. Already established that. This is the only place that -10 reference is used, too. Let's meander it. We meandered our trace. There we go. Nice meandered -10. And then the other side of this goes to Grand. Let's get one of these. Just ground like that. That actually can go up like that. There we go. Okay, so that goes to ground. And then the wiper goes to a 200 kilo ohm resistor. I've got plenty of 100Ks, so I think what I'm going to do is I'm going to use 2 of these to make our 200. And our 200 kilo ohm then meets up with this trace here. So if I'm going to get from here to here, what am I going to do? I mean, I can always... that there. It's a little shorter than that. We'll go to about there. I think that's accurate. We'll see. Just doing this kind of by eyeball. So from this junction here on the 2 point whatever K, and then to... there's already a pin there. You dumb. Why are you dumb? Shorter. Needs to be shorter. This is a little bit simpler than I thought it was. We're getting through this pretty quickly. Should be able to get to testing today. Figure out what this thing is doing. I gotta figure out what timber looks like on a scope. That's really the drive for this project, is my curiosity about what the hell timber is. What could it be? Okay, so if we go from here to this middle pin, I'm just going to do that and then go over and then down. I'll lift the white wire and put this under the white wire. Oh, now I can't reach. Oh, good. Do I not have enough? It's annoying. Oh no, it's just bent funny. It's bent in a funny direction. Story of my life. There we go. Damn it! Yeah, this one's going to easily pop out because it doesn't have a lot of wire to go in. So I need to kind of manipulate it. into having enough wire to stay where it needs to go. So I guess I'm going to undo this on the end here. Bend that down a little bit more. So I get more wire into the clip. Straighten that out. My foot's asleep. I really want to wake my foot up at this point. Oh, big wind gust out there. I'm shocked that we didn't lose power. We got this generator like a couple years ago, and it has just been solid, solid, solid. Not that the generator has been solid, because we haven't used it yet. It's been years. Years of the generator and nothing. Okay, so there's a -10. That goes really haphazardly down and over through this 100K, and then through another 100K, and then it goes into the junction with everybody else. Man, that was annoying. What is the feedback resistor on this thing? 49.9? Where do we even get one of those? I mean, 50K. If I get a 50K and I find one that's just a little bit off. I have 56K and 47. That would mean I need a 3K that's just a little bit off. I have a 3K3 and a 3K9. Wait. 49.9. 47. I need 46K in order to make that happen. 3 point... Ugh. Do I have a 2.9K? No. All right, hold on. 2K2, 1K5, 3K3, 3K9, 6K8, 7K5, 56K, 8K2. None of these are round values, are they? 39. I need 49.9. Do I have any other 9s? No. Oh, I need to wiggle my toes a little bit. Hold on. And try to get my legs back. 47K is over there. 49. 2.9. What do I have in the 40s range? 39, 56, 68. Jeez. Nothing in the 40 range. This is sucks, is what this is. These very specific values are all for analog tuning, and they can kind of be tough to find. Combining is usually the way that you get there without having the actual part. But 49, 48, 47, 46, 45, 44. I don't have 44K. 47, 39, 33. I can do a combination of 3 resistors, but I think that's going to be a little bit weird. 49.9, well, 25K. Something like 24K. 22K, that's not quite it. 33, 39, 47, 56. Damn. I mean, there was a combination where you put them in parallel that I think I got close to that value with, but calculating out the parallel resistors, that would require to be 49.9. That's kind of tough. Paralleling it, though, gives us a different kind of like dimension. We're not just adding them together. $47 plus 2 point whatever I can get. Which I think is only 2.2. So we'll be off by a little bit. I don't have 50K. I have 56. So 47 and 2.2. And these are all 1% resistors, so they'll be very close to the value that they're in. Which 49.9 should be easy to get in 1%ers, but I don't have 50K resistors in here. It goes from 68 to 56 to 30, or sorry, to 47 and 39. And I don't think I don't have anything like 10.9 or 11. 6.8, 7.5, 8.2. Then it jumps to 15. I do have 10Ks over here. But that would mean I would need 39K. Oh, I do have 39. Wait a minute, 39 and 10. That'll probably do it. $39 and then a bunch of 4.7s. 39, that's 100, that's 1. Where are the 10s? They are probably these. Oh no, there they are. 10. You can measure that one out later. And that is the feedback resistor. So I'm gonna have to kind of make a weird jump here. What up, Haystack? How you doing? Doing a little circuit work. Doing a little simple circuit work. Hoping to make things work. We can jump over to like here. But that means making these short. I don't really have anywhere else to do it unless I jump down here. So I think just making them real short and then doing a quick little jumpy poo. And then I'll have to add them up and see what they come out to. But I think that 0.9K is going to be lost. Yeah, jump the shark. I've been jumping sharks this whole time. I haven't even begun to jump sharks. You'll see. I'll get on my motorcycle. I think I've watched that episode. Happy Days. So there, and then the one next to it. So here. So now I need the other resistor to do kind of a weird thing. And one of the leads over. The other one just directly against the resistor. I could do it vertically, but I don't know. I try to avoid the vertical resistors in perf boards. Oh, this is sticking up still. Hold on. That a little shorter. So right here to here. So I'm just jumping it out to an open space, and then I can jump it from that open space to where it needs to go. I don't like, you don't want to keep these exposed leads near each other. See the resistors hitting up against that one. Nothing surrounding that. This has some openings over here where I could potentially put like a wire if I need to, but if I go from here to there, it's not quite, I think I'm going to go from here to there, and we'll just do it that way. I'll have it stick up a little bit. There's an airplane overhead. We had a lot of rain here. Again. Kind of like something weird is going on with the environment. It's the trees. The trees are making us kill each other. This one I don't like, but I don't have much choice. I'm going to have to separate that out a little bit. Just make sure we don't hit it funny. I guess I'll move this up. That'll give us a little bit more space than the wires. Oh yeah, and this one too. Holy shit. Holy shit. Could have really hurt something there. That's a little better. Although this one seems to be coming out. Yeah, it's not making contact. Gotta make sure these make contact above all else. I guess I could go up here and down, but that's still pretty sloppy. We're getting sloppy as the parts stack up. You know what? Maybe this is better like this. It's a little bit more of a diagonal trajectory. Yeah, that is actually better. Why isn't it bending? Weird. Okay, so there's that one. So together, they'll probably make a little less than 39.9. I'm hoping they're at least over 39 because we've managed to make 39. I'm not going to add a third resistor in there to make an exact value. because the output of this thing is not going into a microcontroller. Or sorry, it's supposed to be 49.9. 49. Oh, I've got 49.92 for just a second there. I'm getting 47.15. That's not the value that I'm looking for. It's 47. This is a 10K and a 39. I need 47. That's exactly 10K. This one's 37.9. Wait a minute. Did I use the wrong resistor? What's this one over here? That one's 47.13. 2.2. That's 4.7. Let's see. I thought it said 39, right? Well, what the hell is that noise? This one says 39 on it. Let's check it with the multimeter. That was a really loud noise. I don't know if that was a truck outside or what. 38.7. Why was the other one 37? What the fuck? Oh, it was the sliding door. I'm right below the kitchen, so it's like the most used room in the whole house. Yeah, what the hell? These are 1% and they're 38.6. Cheap pieces of crap resistor. I mean, these are like, you know, you just order them on Amazon by the bushel. But these are supposed to be 39K. Much to my chagrin. Man, I really need to pick out Fallout 4 and actually play the game. But I don't think I'm going to have much fun with it unless I, like, mod it to hell and just do the plot. Because I got hooked in the building mechanic way too hard. These suck. These are all below 39. None of these are quite 39. What the heck? And they jump up to 47 too, so it's not like I can make the value that I want that way. Well, our gain's going to be off by a little bit, but I think it'll be okay. Our gain is going to be a little bit slap happy, but we'll just take that into consideration with the rest of the circuit. I think we're pretty much built at this point. I don't know. What else do we need? We got this feedback there. Oh yeah, the output from that one needs to go to here, to this output. So that's another one that I'm just going to wire up behind everything. Get a nice long wire. Nice long whir. Go from doot, doot, doot. There. Out and around. And then we go to... Oh god. This one is the output. We'll just sneak in there. That doesn't need to be this long. I can use a much shorter one. I'll use blue. That's not blue. Where blue? Where blue? They're blue. Okay, let's just make a mess out of this wire thing. Doot, doot, doot. Ground. This is output over here. Going right here. Hey, what's up, Bring GG? How you doing? I got a bunch from Ollie that's tighter than those. It's always a gamble. It's always a little bit of gamba. And sometimes when you gamble, you lose. And then Waddle's like, That's my Waddle impression. Why is this thing? Why are you fighting me? There you go. So yeah. So I got in, out, modulation, and then what's that word again? Hold on. Scroll. Timbre. Modulation and timbre. And I got everything hooked up. All of our negative 10s are hooked up. All of our positives are hooked up properly. We've got plus minus 12 volts on the TL074. We have all of our 100Ks and stuff. The only thing is that this value is off by a little bit. Is there another 49.9 anywhere? I don't think there is. No, we got it all. I got everything. Yeah, these are all very thin leads too. They're all extremely thin leads. So they're very difficult to work with these, which is why I like to keep them as flat as possible. I don't like to let them stick up. Some people build these things and it's like a big bird's nest. And I guess that speaks to the reusability of the parts that you have, but I don't know. Cool. So the next part is we get to hook it up. Now that 49.9K, the gain's going to be off by a little bit, but we get to see what the rest of the circuit actually does. That's sort of the important part here. And I guess this circuit is probably not going to do what I want it to do, which is a very specific thing based on how this oscilloscope project is supposed to go together. But then I ran across the circuit and I was like, timber, and then a tree fell over and I was like, what the fuck? And so now I have to figure out exactly how this thing works. I want to know what that means. And you know, you can look it up and you can listen to music samples of what timber is, but I want to see it on the scope. So, test setups usually look like this, but we can make it a little cleaner. So, I'm going to need yumpers. I need all my resistors to kind of pack away. Oh god, we've done a number on the resistors. Every time I use this, I need to reorganize it. Bother, why don't you like through hole? Why do you prefer surface mount? Yes, why not? Why don't I prefer surface mount? I wonder, maybe if I thought harder, I would have a good answer for why I don't like through hole. Crap. It's obsolete. All right, and then get this thing just out of the way. Don't need pin headers for now. We need these. I need a short white jumper. I'll take a red, a yellow if you have one. You guys got, do you have a yellow? There's a yellow. Yellow's nice because it always denotes plus 12. At least in my book. In my mind of minds, my mind's heart, my heart mind. This is what is going on here? This is what is this? Listen, don't give me the answers. I've tried to get through this circuit and figure out what it does, and I'm at the point where I need to see it on the scope. And then maybe we can make a determination from there. Everybody wants to be the smart boy and answer all my questions, but sometimes you got to show people this part of the whole process because it's good to know. Good to see. It's good to see other people doing instead of everybody just knowing what everything does all the time. That's what frustrates me with YouTube. So we're going to figure this out experimentally. I had a bunch of number buttons. Is that beeping I hear? Don't tell me there's a battery that's out of... smoke alarm that's out of battery. By the way, this scope turns on very, very quickly indeed. It takes 1 full minute to boot up, which is ridiculous. It is a wonderful scope, and I endorse it to the ends of the earth. Rigel has not paid me. They have not sent me a scope. I wish they had. I wish they had. I'm not cool enough. But still, it's a good scope. I need to make shorter little adapters for this. These T-junctions were a little too close to the scope, and they were kind of damaging the BNC connectors, so I've made little jumps. I should get little shorter ones than this. Little yumps, and now I can do pass-through connectors on these. So one of these will go I just start the whole thing over. One of them will be input and the other will be output. So input is coming from, drum roll, my frequency generator, my frequency generator, which gets this power supply, right? 3 amps, 12 volts. This thing is, I think this one's 15 TVH. Do we have a, we don't really have anything that tells us what the input is, do we? Damn, what is this voltage? Well, I guess we're giving it 12 volts, so we probably can't get, we might be able to do -5 to 5 on this thing. I'm not totally sure about that. This is the charger that I've kept next to it, so it's probably the one that I've been using in the past. So we'll plug this in over here. Get that power behind everybody. Let's get the soldering iron out of the way. I can never get away from the what just fell down? God damn it. It's one of my things. All right, so over here is our input frequency generator. That is going into our yellow trace. These are a little bit stiff, these wires. You know, the problem is it's Twitch numbers don't really translate that well for people who are looking for like an advertiser to like get with. I've had a couple that have tried and they were kind of scams. Kind of. They wanted you to sign into their like network and then you have to like let them manage your money. It's like I don't really want that. So I don't know. But like some creators get all of these wonderful freebies and I'm wondering how. A lot of the thing is like doing YouTube, your numbers are much larger. Like, you know, 500 views on a video is pretty cool. I get like 23 because my videos are 5 freaking hours long. Nobody has that kind of time. But that sort of thing gets you, you know, big number. Look at big number. Look, big number, go up. You know, that kind of thing. Twitch doesn't really do that because they're a number of live views, not overall number of views. I don't know if we're putting this into anything else. So I probably didn't need to use the BNC for that. Yeah, well, they can get stuff. I can't. I've never had anything sent in that wasn't from a viewer, which I love you guys for. Some of you are really adamant about sending in things and have been able to negotiate my address from me, but you know, you got to do that through Discord. I'm not popular enough for a PO box. Those are expensive. Thank you. This scope is a gift. It's a birthday gift to myself. It was many dollars, and it is a cream of the crop kind of scope. It's my first really good scope that isn't just a, oops, I touched everything. That isn't just a, I mean, it's still a Rigol 4-channel, but it does have logic analyzer stuff in it, which is really cool. And we haven't even touched the surface of what this scope is capable of. But part of getting this scope is being able to do this. My dog is just barking in the background. This. No, wait. It's being able to do, where the hell is that thing? It's being able to do that. Why is that so fast? No, that's not quite right. This, there it is. Having this display be like real-time 60 frames per second. Cool thing is you can go to an intranet site and you can click on that screen and change stuff. I could do an OBS plugin that would influence my scope. We don't need this on right now. I'll turn it off. Boom. I need to make a Stream Deck button for that. Okay, so I mean, even though it's just power to power, I need to make something that clips to these boards and has the modular synthesizer power plug. When I say plug like that to my dog, she tries to attack me. It's horrible. So plus is on this one. Yeah, so the opposite of that. Okay, so this is plus. Oh my god, why is my dog going nuts? Quiet time is streaming time. Why are we so loud? Shut her up. Close the door. Jeez. I'm trying to do a production here. She's the cutest dog in the world. So she gets a lot of leeway when it comes to barking. Smart dog. Okay, input, output, and so our input is, well, this is saying 10 volt plus 5 volt. 1 per second square wave. What were we doing before? Let's make it like a 130 hertz. No, not second. I'll try to make it hertz, but it won't go to hertz. Frequency. 300 hertz. 300 hertz square wave. Let's change that wave. Nope, that's right. Where do I do this square wave type? Offset should be 0 volts. No, it doesn't like that. Offset, it can't do 10 volt. It needs to be 5 volt. Yeah. No, get out of this. How do I escape? Escape. This thing is a very rudimentary frequency generator, but it does do some good stuff. Should have bought a Rigol. What'd you get? Or did you not get anything? Amplitude, 5 volts. Okay, amplitude. 4 volts. There we go. Offset, 0 volts. 4 volts plus and minus 300 hertz. It's currently a square wave. I guess we can try that. That's going into channel 1, and I'm not seeing it on channel 1. Is there an output on and off? No, this should be outputting that wave right now. I'm not seeing anything. So channel 1 here goes into channel 1 here. Unless my shit's broken. On channel 2. Channel 1, 2 volt per peak, 4 volt positive and negative. No power going into this thing, but then again, we're not referencing off of that. We've got 12 volts and ground, whatever ground this thing is providing with the output. Choice is approximately between OON and Handtech, because the budget is tough. Yeah, the splurging on a Rigol was mainly because I'm running a stream here, and it's good to have the ability to put the... I've wanted to have that on-screen scope ability for my entire streaming career, and Rigol knocked it out of the goddamn park with the features that this scope has. You know, they have the web interface, it's fast and all that stuff. So partially because, I mean, I guess it's Android based now. Why am I not seeing anything on the scope? I really should be seeing something right now. That one's the other input. This one's this input. Well, there it is. Just had to squeeze things a little bit. Oh, I see. These connectors are... They're a little bit wonky. All right, so there's our input wave. And our input wave is positive and negative 2 volts. I guess that's a nice safe spot for this thing to be in. Repair money, huh? So now we need to get our power into our unit over here. And I'll just insert our square wave into our system. Like so. And then we'll disconnect power here. And then I'll turn this on. And so plus 25 volts. Of course, we have to turn, because it's an Agilent supply, we've got to turn the output on in order to adjust it. 9, 10, 11, 12. Minus 25. Goes up to 12. And then we can hook this up to everybody else. Turn it off first, just to be nice to our electronics, because I don't want things to blow up. Non-stripe side is plus. Ground is in the middle. Stripe side, minus. Okay, so this is where, if I was actually running an operation where I didn't want to blow stuff up, I would double check over my circuit. Once everything's hooked up and ready to go, before I hit that power button, I want to go over the circuit a little bit before turning it on. But I'm just going to send it. We're just going to send it immediately. Well, we need thermals, so I don't want the scope to cover thermals. Regular used to be the budget choice back in the day, but they had those models with the tiny, tiny screens. Yeah, I have one of those budget ones, but now they have huge screens, and they're still an affordable price. It's just, you know, budgets have moved on. So the first thing we look for, because I have a thermal camera, and that sets me apart from anybody doing this DIY, is that I have a thermal camera. These things are getting way less expensive these days, though. We're starting to run out of excuses for not having a thermal camera. But because I have a thermal camera, I get to look at heat. Heat is the killer of electronics. Heat is the mind slayer. Heat is the killer of electronics. When something starts dying, it starts heating up. And when it heats up, its resistance goes up. And when its resistance goes up, it heats up more. And then that eventually cascades into stuff blowing up, which would be really advantageous to us because if stuff blows up, it's fun. But what we're going to do is we're going to turn the circuit on to, oops, what did I hit? We're going to turn the circuit on to 12 volts. We're going to see what happens on the output and then see if we made any mistakes in our circuit. Here we go. 3, 2, 1, go. Boop. Anybody heating up? We don't really have any output. But then again, maybe I need to modulate it in either direction. Nope. 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 Okay, so we look at the output. Plus 12, minus 12. They're both at 0. Are they both at 0? Everybody's plugged in. This stuff should be good. 0 amps going out of this. Positive 12 over here to positive 12. Ground to ground to ground. And then minus 12 down here. Minus 12. By all means, I should be seeing something. Yeah, we full send on this channel because I'm streaming. Because I'm streaming, we full send. Otherwise, you guys should never full send. Unless you want to have fun with electronics and want stuff to explode. In the off chance that something blows up, I just send it and look to see what heats up. Why do you forsake me? Why do you forsake? Oh, I'm plugged into the wrong row. There it goes. Now what's happening? Channel 2, where are you at? You have negative 6 volts. Uh-huh. That's a lot of volts there, bud. That's a lot of volts there, bud. You shouldn't be able to be this many volts. Interesting. Anybody heating up too much? Oh, yes, my negative 10 volt source is heating up. Let's go ahead and turn off the supply. So, what did I mess up? Possible these two have a little crosstalk going on. Let's try moving that a little bit and try again. There should be no way that this is able to get up to the voltages that I got up to. Whoa, what was that? Oh, well, output is off. Hold on. Whoa, well, there's that. It really shouldn't be able to get up that high in voltage. That's like, that should break it. The signal generator is a DIY kit, yeah. Why are you at 11 to 12 volts? And why is my negative 10 source heating up so much? Minus 10 goes there, goes to that end of the potentiometer. The other end of the potentiometer goes to ground. AREF minus 10 goes there, the other end goes to ground. It's a 10 kilo ohm resistor that has a 200 kilo ohm, 200 kilo ohm output. Oh, there's an LED on the power supply. That's cute. I didn't know that. So then, ground there, 10 volts there. What that does is that does nothing. So let's probe around and see what's going on. So let's get channel 3 in here. Channel 3, I need a probe for. I had a probe out. I saw it just a minute ago. Where did it go? I want to lose my probes. I want to keep my probes. I want to keep them around. Maybe it ended up back in here. There it is. So it's 300 hertz, square wave, 4 volts. I'm gonna go yell at my dog. Where's channel 3? All right, let's try to trigger on channel 1. Trigger, channel 1. There we go. That stabilizes things a little bit. Channel 3 is nowhere to be seen. It's way up top. Why is it so high up? Did I hook up ground wrong? Oh, those aren't going to ground. They're going to negative 12. Hold on a minute. Hold on a minute. Turn everybody off. Shut it all down. Wrong reference. That was a bad reference. Very cringe. Now they're on ground. Yeah. Yeah, I mean, there's a lot of advantages to using this stuff. Okay, so now there's a bit of our square wave. I don't know what Timber's doing. But it seems like we lose the square wave if we go anywhere off of exactly the right spot. And this thing's heating up. Are we actually getting negative 10 here? Why is this thing at like 50 volts? What's going on here? We're at X10. So there's X1. It's just, why is channel 3 way off? What's going on? Those two seem okay. Channel 3 should not be. Over 40 volts? What's going on? All right, channel 3, let's just take a look at, what's the channel menu? Coupling is DC, bias is 0 volts, unit is V, label, etc. We're not using advanced routing. Scale for now is 500 with a 3.5 volt offset. Oh, there we go. That's the problem. Okay, so if I click in the thing, it'll unoffset it. No, wait, click in this one. There she is, reading my ground potential. All right, turn that up to 5 volts, and then take a look at what's going on here. Why is there a square wave here? No, wait, that's negative 10. Okay, so our negative 10 source is making negative 10 volts. That's at negative 10. This one is at ground. And so if I adjust, it goes all the way down to negative 10. Okay, so yeah, there's a nice little adjustment from 0 to negative 10. Right? So that part is working. For some reason, it only works when it gets to 0 volts. There's something else hooked up wrong. There's 0 volts. This one is negative 10. This one is our output. And then that one goes to here, which goes over to here, which is this part. So it's 200 kilo ohms, and then it reaches our combination with everybody else. That's where we get a 24.9K coming out of that other op amp. That goes to ground. Ground is here. That's definitely grounded. This one is positive 12 volts, correct? And then that's a TL074. The other amp is probably being all crosstalky. Doesn't really matter that much. You can see that one adjusting a little bit. It's just this other one is going from square wave to nothing. What's going on the input to this one? Got a bunch of different stuff combining. Wait, is there a math menu open? No. Well, channel 2 is acting differently now. Is it a matter of poking my electronics so that they start working properly? Too many connections and there's too many unknowns? That certainly doesn't feel like timbre to me. Why did this menu suddenly come up? I mean, it could just be that the 10K, or no, it's 100 ohms missing from the feedback resistor puts it into saturation much more easily due to the math. The bath. Oh, my life. Oh, my life. Oh, this one's 100K. Well, that shouldn't matter. If it's 100K and it is which one? That one is the timbre adjust. No, that one is the negative 10 volt adjustment. So that actually is fine because this one is just acting as a voltage divider. And of course we can observe it acting just fine. 0 to negative 10. Oops, well, now it lost that. You get out of the way, negative 10. And then, let's see, so over here we have 1. This should be, oh, wait a minute. That might be it. So input to here. Now that goes through 100K and then it goes to there. And then this one, what the heck? Oh yeah, that one's going over to the TL074 on the, yeah, that's on the positive. So there it is going, no wait, no, I'm not observing it at all. I don't see it at all. What the heck? I should be seeing it, because one side goes to nothing. Oh, wait a minute. Oh, I didn't make that circuit jump. No, yeah, it does. It goes over to here, which goes to the input side, which goes to a bunch of other stuff. Goes to a bunch of other stuff, including the feedback resistor. And then the other side of the feedback resistor goes to a ton of other places where I'm observing it right now. So this is doing nothing, but its buddy basically enables our output waveform. There's a couple little shaky connections on this, though. Am I connected to the wrong part of this? That might be the case. This should be the input. This should be the output. These should be disconnected. Okay, they are. Never mind. Disconnected stuff is where it's supposed to be. And the connected stuff is where it's supposed to be. Where'd channel 2 go? Why is that missing? Hey. You come back. You don't, yeah, you stop lying to me, channel 2. There you go, same scale. We need a little bit more for channel 3 because we're probing voltage too. I mean, the output of this is supposed to be what the microcontroller sees. Oh, here we go. Well, modulation isn't doing anything, but timbre is offsetting it perfectly. Although, to be fair, the output from the TL074, or from the MCP 6002, is not supposed to go this high. It's not supposed to be able to do that. This thing's just warm. It just naturally gets to like that. Why is it able to do this? Wait, what voltages are we looking at here? Oh, I see. Okay, so maybe it is able to do that. Oh, this slipped. Whoops. There we go. Now we're just back to where we were. I was doing something interesting before. Now it's just broken again. It's like square wave or no. I mean, I don't think I'm going to get any difference from a sine wave. Let me try to change the sine wave. How do I choose the wave on this thing? Servo run. Continuous wave is what I want. And then, how do I adjust the wave type? Wait a minute. Oh, WF, there we go. This thing sucks. This thing sucks. It doesn't have, the controls are kind of tough. Triangle, sawtooth. Give me a sine wave here, Bubby. That's a custom one. There's my sine wave. Why are we sine waving into... All right, try lowering one of these. Nope. That doesn't appear to do anything. And timbre is useless. Okay, so, I mean, we made a little progress. Our output is now some type of square wave. Got to figure out where the error is, though. So let's just check our voltages. So input over here. That should, oh wait, no, right here. And so there's our input. Although I'll put it at the same scale as the other one. There's our input. Matches what we see on the scope. It's right there. Here, let's do a microscope on this. That way things are a little bit more more clear what's connected where and where I'm probing. Oops, wait, yeah, we don't need this schematic. Although it would be good to have the schematic alongside of all the rest of this. I'm running out of real estate. I guess we know that there's no thermals, so I'll just paste over this stuff. No, I'm not saying these fucking gorillas, man, not Britney Spears. Let's see, scope there. Yo. Okay, so now you guys can see what I'm doing. So yeah, input is on this one. We can see it matches the input over there, although there's a little less resistance on it there. But yeah, so that goes there, good. There's nothing here. And so what that does is it goes back and around. And there's one made up of sine waves. Probably one mewling about a sine of some kind. I don't get what the orange is doing there. What is the orange doing? Do I have a math menu open? No, not really. There's like a red in between everybody. Yeah, everything's off. Math 1. What about math 3? Everyone's off. Man, this thing's powerful. Okay, so over to here. Right, same wave. And then it goes into the center tap of the 10 kilo ohm resistor R37. And that's right here. Right here. Okay, wait a minute. Okay, there it is. Pretty weak, but it's still there. Is this affected at all? Nope. Excuse me, I wasn't able to cover. Hold on, I'm gonna cough. Got this like dust in the back of my throat. So anyway, it's pretty weak there, but it's still there. This is on one end. This is on the other. What's going on there? I think that's the measuring that's going on. I need to turn this off. There we go. That's the full scope. Let's zoom in a little bit. I'll turn the trigger down a little bit so we don't lose it when I connect stuff. Hard to see that there, but it is there. It's not changing with as I change the knob. I mean, I see it changing very slightly, and I should probably squish the wave a little bit so it looks... We can see the actual other frequency moving. One more. That. I go here. See, now it looks a little bit more prominent. Oh, what did I bumped something and now everything is actually doing its job? Everything's doing its job. So there's an offset. This actually might be doing exactly what I want it to do in the scope. This thing doesn't do anything. Well, like if this thing's doing that, that's what I want it to do. I think. Well, yeah, it's going from it's doubling it, and then it's also limiting it at 0. So I guess that's timbre, but that appears to be what the mutable instruments circuit does. Sorry, the Hajiwo circuit does as well. Because the Hajiwo circuit here, according to what I'm calculating with the plus minus 5 volt cut here, although mine is 3.3 volts, with the plus minus 5 volt cut here, it'll just cut this off when it gets too high or low. And so will this if it's only limited to 3.3 volts. So if you double the input here, but that's actually, wait, that's not doing the right thing. No, because this is an offset. Yeah, timbre is not changing the amplitude. This is modulation, and it's not doing anything. So why is modulation not doing anything? Is this still, well, I can't see if it's heating up still, but so modulation is our signal input. See, this one is just plus minus 10 volts, right? So this one goes from 0 to... Oh, come on, where's my... See, that just goes from 0 to 10 volts, negative 10. And so that gets us our whole range. If we took half of that by biasing it with a 200 kilo ohm resistor, then it would bias it to the middle of what, you know, this thing can do. This should be the input wave, though, minus 100K. And currently it is nothing. Oh, good. Then that broke. Got the power to do that. Huh. It's doing other stuff. It's just that the circuit, the construction of the circuit might be lacking some connections that are needed. I see it's doing that square wave thing again. I don't think the purpose of this is to turn it into a square wave, though. What's going on there? Yeah, that just raises and lowers it. Oh, here we go. So that modulates it positive or negative? Is it just biasing between the 2 amps? Because what's happening when I do that? What's happening when I do that is we get... Yeah, I think I just had to poke the right parts, and this may not function going forward. This is a result of using these friggin' 1% resistors that don't necessarily make a great connection with the board below. I almost feel like I should double the wire up and just drop both of them in. But what this is doing is it's biasing this signal to go either this way or this way, to bias it in favor of one or the other. 24.9 and 49.9 though. So what does that even mean? Why does that invert? One of them acts as a feedback element, but I don't understand how that's... That is changing the amplitude of the signal, though. And this is positioning it. That might serve the purpose that I'm looking for in the circuit up here. Without the filter, we have a bias, a protection circuit that the op amp would do anyway, and then we have a 1 to 2 amplification stage. This would be the offset, the 2.5 volt offset, I guess. No, but then again, the 2.5 volt offset, no, that doesn't quite affect it the same way. It's just a little bit different from that. And then this isn't really an amplitude. This is sort of an inversion. So, okay, so this circuit, I mean, I knew it wouldn't do what I wanted it to do, but timbre is a strange setting, though, because it sets it against the limits. I guess this is probably where it would go to if the op amp was biased correctly. Strange. Square wave is totally boring. Yoink. Yoink. And then triangle. Yeah, so I don't think this will be functional for the scope. I don't think this will be something that I want on the scope itself. I mean, as a means by which to locate the waveform, I don't need this. I don't need it to reverse the waveform. That's kind of a faux pas. So many ramps. So many ramps. It just hits it with everything. All right, cool. So we know what that one does. Oof. Oh man, really? Were we only able to get through the one waveform today? We're only able to get through the one waveform today. I'll have to look up some others and see if there's something that does what I want it to. But between a voltage-controlled input and a low-frequency oscillator, what it really is for a wave shaper, I guess, is what it, I guess. Let's see what it is. Mutable instrument schematics. And then these are all over the place. And so I think it might be, is it Braids? Yeah, it is Braids. So I got this from Braids. Braids has a huge numerical output on it, and it uses the STM32. Yeah, STM32, which is torture to use, but it's good if you're good at this stuff. But Braids has, for the input of the CV, I took this one because it's got the 2 controls on it. So I was just seeing what it does, and I was like, wait, what in the world? How does this function? Tonewood debate? I don't even know what that is. So Mutable Instruments Braids. CS80 style sawtooth with a notch, continuously variable morphing between triangle, sawtooth, square, and pulse with character control. Triangle design morphing with a wave folder. Band limited dual bowl strain, blah, 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 blah. It does a lot of stuff. But I was just specifically looking at the timbre control. Meta mode. 12-bit CV capture, 96 kilohertz, 2x5. Power connector. Yeah, so anyway, this is, you know, I could always get the parts and build one of these modules, but I'm just looking at the Mutable Instruments circuits are good when you're using a 32-bit, or sorry, a 3.3 volt microcontroller to do all of these wonderful tasks. So I'm bringing these things in, and I'm like, well, what can I do with these circuits? And it looks like this is probably the origin of the other circuit. It would be, this one would have the analog reference already offset, and you could set it to invert or go regular. And then this one is just changing that offset positive or negative, and it always comes in the same way. If you want to adjust that offset, I need an amplitude control, so I need something on the feedback with a 10K on it, I believe. So I'm gonna keep searching with Mutable Instrument circuits and see if there's something that I want that does what I want it to do. I think there's one of these has like a dual pot on it. I think it might be Clouds actually that does that. But I'll take a look and I'll see if I can find something that we can breadboard that will serve the function of the Hajiwo circuit, but does it in a way that, you know, I like. I don't know if I totally appreciate. I mean, this is fine. This is perfectly fine. It has this weird additional 2.5 volt offset that I'm either going to have to make a 1.6 volt offset for, or I don't know, I'll have to come up with another scheme that achieves what Hajiwo wants out of this thing. So what Hajiwo has happening is over here, he has a PWM outputting that will then translate into 2.5 volts and feed this. And so if you don't output the PWM, it'll be at 0 volts. But I don't really like that. That's kind of a weird way to do it. You could just have an activation voltage here, and we'd have to find the areas in code where it goes to output D3, and then we would have it switch the offset on and off. But aside from that, I want to affect this kind of change possibly within an op amp, and so I need to learn a little bit more about how op amp circuits are doing what they're doing. And that was sort of the whole purpose of what we put together today, is just testing and seeing what something like this does with the circuit. And you can see how easy it was to put together. A little bit of growing pains. We don't know exactly why it worked in the end. Mostly I was just poking around this area, and it decided to snap back into reality. Oops, there goes gravity. But it does work now. And you can see that I've been building up stuff for this setup. I've got all of the hookup stuff that I need to give you guys the full picture of what's going on when I twiddle knobs. So this is a lot of fun. This is very eye-opening. It was a pretty easy circuit to put together. We managed to scrounge up almost to the exact parts. I think that top area cutoff, this cutoff at the top right there, I think that's caused because of the discrepancy between our 49 point whatever pot. What's up, Copper? We made a timbre and modulation circuit today from Mutables. This is apparently timbre. I don't know why. All this is doing, so what this is doing is into the analog input, you have a 0 to whatever voltage. Let's see, which one is that? Number 2. Oh, why are my voltages on the right? That's weird. See, this doesn't go over 3.3 volts. It might go a little bit. It doesn't quite go over 3.3 volts and doesn't go below ground. So you got this little cutoff point on either end. mean, if I combine that with an amplitude, that would actually be pretty good. Hey, what's up, Gonad? I saw you streaming today. Where's my raid? I'm just kidding. We made a cool circuit today. I guess we should victory lap for a little longer. I never get to victory lap on my show. You know, we solve something and then we almost immediately throw it in the garbage. You ran out of energy? You lost me, but this is interesting. So the reason that I did this is because I had to. You didn't die. Good. I don't want you to die from streaming. Please don't do that. Yeah, no, you're too good of a friend. Copper can die from streaming. I don't give a shit about Copper. I'm just kidding. I'm just kidding. I hope you guys stay alive in Minecraft. Anyway, without this filter here, I'm trying to accomplish the same goals as Hajiwo set out, but I ran across this circuit, and this circuit was a modulation and timbre circuit, and I tried to come up with the equations for this. And I guess if I ran the numbers, I would probably see that this thing is inverting the signal. So it goes between positive and negative inversion due to the transfer equation, the equation that the op amp utilizes in this configuration. Because we're summing it. We're summing a negative 10 source, and that's what's giving us our offset. We are sending it either through an inverting circuit or no, because they're both inverting. We either invert it and invert it again as, I guess, a half and half. Or we give very little signal to one end and we give very much signal to the other. And that just accomplishes wibbling it in the opposite direction. So that's kind of cool if you want to have weird interactions with your sounds, if you want to have it cut off at either end. Because I don't know if this will go to 5 volt. Hold on, let's go amplitude 5. Oh, that's wrong. You hit the button twice for some reason. All right, so there's 5 volts. Which means, yeah, it crashes harder against the edges. So not entirely useful for this little thing right here. This little thing, that's not very useful for the a display module. Now I'm waiting for the screens in the mail. I think I too have run out of steam, unfortunately. So we'll I'll try to get together another circuit for Tuesday. Because my next stream is on Tuesday. There's too much stuff going on around here, and it's tax season. I have to figure out what to do about my taxes, so I'm going to do that over the weekend. Fun times over here. And we'll be back on Tuesday. Maybe we'll try some more circuit stuff. I know I need to get back to Burn the Subs, and we will. But there's a couple projects that I need to kind of look at in the interim. I kind of want to finish that VCO. I might just do that off camera and then show you guys it working properly, because all the rest of the stuff that I need to do is like little tweaks and tunes to get everything up and functioning. Yeah, I don't have much going on. Confused by the new phone and Apple's ecosystem. Oh my God, that sounds ridiculous. I would not like to go over to Apple. I'm happy with Android, especially because of the health monitoring stuff that I've got working on Android. But yeah, I'll be on Discord. You guys can catch me on Discord. I'm going to do the end card. OctoJ apparently missed it for a week and none of us noticed. We'll see if he's done it. 3 days, 19 hours, 53 minutes. I think that is updated. So you can catch me on Discord and Twitter if you want. I'll mainly be on Discord, but I got to go shuffle things around upstairs and help people out with stuff. So I will be around. I'll probably be debating on taxes if I even need to fill them because I didn't make enough money. I think I still have to do state taxes, so I don't know if like Free Tax USA lets me do just my state taxes. But yeah, I'll be around. And hopefully I'll be able to take the RC car out and see if I can crash this up against something. More modular work on next week. I'll probably take a day and just burn the subs over here and work on it. But today was so much fun with the breadboard. Like, we were able to get an entire circuit down in one go, and with, whoa, what was that? With just a little bit of poking around. Did you guys get that? Is it super slow? I just got like a weird, super slow frame rate. That was very strange. I'm scared. Enjoy time with Willow. Oh, I definitely will. She's been such a goober these past couple days. Now that what's happening is everyone's home, and it's killing me because I can't poop without somebody
walking into like next to the bathroom, and it's like, stop it. Anyway, it's a wonderful thing about living alone is that you can poop on one floor and go to another one. Not like on the floor, I mean like on one level of the house, like the bathroom on one level.